Right now, Texas construction crews are building some of the biggest and boldest megaprojects the state has ever seen, and they're only getting started. From billion-dollar highways to high-speed rails, these projects are reshaping the future of Texas in real time. In this documentary, we reveal Texas megaprojects under construction in 2025. The Harbor Bridge replacement in Corpus Christi, Texas, is one of the most ambitious infrastructure projects in the United States, aiming to completely transform regional connectivity and maritime commerce. Designed to replace the original 1959 bridge, which no longer meets the needs of modern transportation or shipping, the new structure is a state-of-the-art cable-stayed bridge that stretches across the Corpus Christi ship channel. Once complete, it will stand as the longest cable-stayed bridge in the United States and the tallest structure in South Texas. This massive project features a main span of 1,661 feet and twin towers rising 538 feet into the air, nearly twice the height of the current bridge. The vertical clearance underneath, at 205 feet, will allow for some of the largest ships in the world to pass safely, supporting the continued growth of the Port of Corpus Christi, which has become one of the nation's busiest energy export hubs. The bridge is expected to significantly boost commercial activity by enabling the passage of post-Panamax vessels, a crucial upgrade in today's global shipping economy. More than just a freight route, the new bridge also caters to commuters and recreational users. It will carry 6 lanes of traffic, 3 in each direction, with additional shoulders and a pedestrian and bicycle path, a first for major infrastructure in the region. This emphasis on multimodal access is part of a broader effort to modernize transportation while promoting sustainability and public health. Have you ever seen a bridge built to last nearly 2 centuries? Engineers designed this structure with an estimated lifespan of 170 years, thanks to its use of post-tensioned concrete segments, a method that allows the bridge to handle immense pressure and shifting environmental conditions with reduced maintenance over time. Despite the project's promise, it hasn't been without setbacks. Design disputes and construction halts have delayed progress, pushing the anticipated opening to mid-2025. But with those issues resolved, construction has ramped back up and is on track to meet the revised timeline. Tesla's Gigafactory Texas, also known as Giga Texas, is a revolutionary manufacturing complex that marks a bold step in the future of American industry. Located just southeast of downtown Austin, this facility sprawls across more than 2,500 acres and represents one of the largest construction projects ever undertaken in the state of Texas. With Tesla's characteristic ambition, Giga Texas isn't just a factory. It's a symbol of innovation, scale, and the company's unrelenting push toward a sustainable future. At over 10 million square feet of floor space, Giga Texas is among the largest buildings in the world by footprint. Elon Musk has described it as an eco-friendly manufacturing utopia, where sleek, modern design meets cutting-edge production lines. The facility is central to Tesla's long-term strategy. It serves as the main production hub for the Model Y, the best-selling electric SUV in the world, and the highly anticipated Cybertruck, a vehicle that has drawn global attention for its unique, futuristic design and stainless steel body. Giga Texas also plays a critical role in Tesla's battery technology. The factory is home to advanced battery cell production operations, particularly Tesla's in-house 4680 battery cells. These new cells are designed to deliver higher energy density, greater range, and lower cost per kilowatt hour, which could be a game changer for both electric vehicles and energy storage solutions. Have you ever heard of a factory doubling as a public space? Tesla has plans for Giga Texas to be more than just an industrial complex. Musk has hinted at integrating elements like a boardwalk, hiking trails, and even a public access area along the Colorado River. This fusion of industrial and recreational use is part of a broader vision to make manufacturing more transparent and community-focused. The scale and speed of construction at Giga, Texas have been nothing short of remarkable. Ground was broken in mid-2020, and within just a year, production began on the Model Y. That pace is nearly unheard of in the auto industry, a testament to Tesla's agile project management and relentless execution. Thousands of workers have been employed during construction, and once fully operational, the factory is expected to create over 10,000 permanent jobs in the Austin area. Did you know Giga, Texas is entirely powered by renewable energy? The factory is designed to operate with a minimal environmental footprint, utilizing solar panels, energy-efficient systems, and advanced water recycling. This aligns with Tesla's broader mission to accelerate the world's transition to sustainable energy. Rising above the heart of downtown Austin, the Waterline Tower is redefining the city's skyline and pushing the limits of vertical construction in Texas. Once complete, this ambitious mega project will stand at 1,022 feet, making it the tallest building in the state and one of the tallest residential skyscrapers in the southern United States. Located at the edge of Lady Bird Lake, the Waterline isn't just a statement of height, it's a testament to Austin's explosive growth and its emerging identity as a major urban hub. The project is a mixed-use development that blends luxury living, premium office space, hotel accommodations, and retail experiences into a single vertical community. The tower will contain 74 stories, offering over 350 residential units, approximately 700,000 square feet of office space, and a 251-room hotel operated by One Hotel, a brand known for sustainability and upscale design. The bottom levels will host restaurants, bars, and retail outlets, creating a seamless connection with the surrounding downtown environment and the lakefront. Construction of the Waterline Tower began in 2022, with completion targeted for 2026. The design is a collaboration between world-renowned architects and developers who have integrated modern aesthetics with environmental awareness. The building's glass facade reflects the sky and water below, while its interior spaces are planned with a focus on natural materials, open light-filled layouts, and energy-efficient systems. The goal is to combine luxury with livability in a way that supports both urban density and sustainability. Have you ever seen a skyscraper with direct access to lakeside trails? The Waterline's location allows for exactly that. Residents and guests will be just steps from the Anne and Roy Butler Hike and Bike Trail, giving them immediate access to one of Austin's most beloved outdoor spaces. This connection between towering urban living and natural landscapes is a rare and highly sought-after feature. The engineering behind the Waterline is just as impressive as its height. To support such a tall structure in Austin's unique geology, the building uses a deep foundation system that anchors it securely into the ground, while mitigating lateral movement from wind or seismic activity. The building also incorporates high-performance glass and a tiered structural design that reduces wind load at higher elevations. Inside the tower, residents will enjoy high-end amenities, including rooftop pools, wellness centers, private lounges, and co-working spaces. Office tenants will benefit from large floor plates, panoramic city views, and next-generation workplace technologies. The hotel portion will emphasize nature-inspired luxury, with materials and textures chosen to reflect Texas landscapes. The Loop 1604 expansion in San Antonio is one of the largest and most transformative infrastructure projects currently underway in Texas. Designed to address decades of explosive population growth and mounting traffic congestion, the project is reshaping a major artery that loops around the northern and western portions of the city. Once complete, this massive expansion will increase mobility, improve safety, and provide the critical transportation infrastructure needed to support San Antonio's future. Loop 1604 has long been a vital corridor for both local commuters and regional freight traffic. Originally constructed as a rural bypass, it has since evolved into a major suburban thoroughfare surrounded by residential neighborhoods, shopping centers, and commercial developments. As the San Antonio metropolitan area has expanded outward, traffic volumes have soared, leading to chronic congestion and long commute times, especially during rush hours between I-10 and I-35. The expansion project focuses primarily on the northern segment of Loop 1604, between Bandera Road and I-35, with plans to ultimately address the entire loop. The most significant upgrade involves the addition of multiple lanes, converting the existing 4-lane highway into a multi-lane expressway with 3 lanes in each direction. Some sections will also include high-occupancy vehicle lanes aimed at encouraging carpooling and easing pressure during peak traffic periods. Have you ever driven on a highway that gets a complete redesign while staying open to traffic? That's one of the biggest challenges facing this project. Construction is being done in phases to maintain traffic flow while upgrading the infrastructure. This involves temporary detours, night work, and a coordinated effort to minimize disruption for the tens of thousands of vehicles that use the corridor daily. In addition to expanding capacity, the project includes significant upgrades to interchanges, bridges, drainage systems, and frontage roads. Key interchanges, such as those at I-10 and US 281, are being completely rebuilt to improve flow and reduce bottlenecks. The new designs feature flyovers, collector-distributor roads, and better signal timing systems to manage merging and exiting traffic more efficiently. Safety is another core focus. The expanded loop will include modern barriers, wider shoulders, and enhanced lighting. These upgrades are aimed at reducing the frequency and severity of accidents, which have been a recurring issue on the current road due to outdated design and high congestion. Did you know the expansion also considers future technologies? Some portions of the new Loop 1604 are being designed with smart infrastructure capabilities in mind. This includes space for potential autonomous vehicle systems, dynamic traffic monitoring, and integration with regional mobility networks. Once completed, the Loop 1604 expansion is expected to significantly cut commute times, support economic development, and improve connectivity between key corridors in San Antonio. With the city projected to gain over 1 million residents in the coming decades, this project is more than just a road expansion. It's a crucial investment in keeping the city moving forward. The Texas LNG project in Brownsville is one of the most significant energy infrastructure developments currently underway in the United States. Located at the southernmost tip of Texas, near the Gulf of Mexico and just north of the US-Mexico border, this liquefied natural gas export terminal is designed to turn American-produced natural gas into a globally traded commodity. As global demand for cleaner burning fuels grows, especially in Europe and Asia, the Texas LNG project positions the US as a dominant force in the energy transition. The facility is being built at the Port of Brownsville, a deepwater port that offers strategic access to international shipping routes. The project involves the construction of a liquefaction plant capable of converting natural gas into liquid form for export. Once completed, the terminal is expected to produce and export up to 4 million tons of LNG per year in its first phase, with potential for expansion in the future. At the heart of the project are the liquefaction trains, massive units that cool natural gas to 260 degrees Fahrenheit, transforming it into a liquid that takes up about 1/600th of its original volume. This allows for efficient storage and transport overseas using specially designed LNG tankers. The gas primarily comes from the rich shale formations of Texas, including the Permian Basin and the Eagle Ford Shale. which are among the most productive in the world. Have you ever thought about the sheer complexity of freezing gas to a liquid at an industrial scale? This process requires not only enormous amounts of energy, but also extreme precision, as even minor temperature or pressure deviations can impact performance. The Texas LNG facility is designed with advanced systems to monitor and control every step of the process, ensuring both safety and efficiency. The site also includes massive storage tanks, marine loading docks, and supporting infrastructure such as pipelines, electrical systems, and control centers. The facility is being designed with an emphasis on minimizing emissions and environmental impact. Measures include electric motor drives for compressors instead of gas turbines, and carbon capture-ready features to support potential future emission reduction technologies. Economically, the Texas LNG project is expected to generate hundreds of permanent jobs and thousands of construction jobs. The surrounding community of Brownsville, long known as one of Texas's economically underserved areas, is likely to benefit from increased investment, improved infrastructure, and higher tax revenues. Workforce training and education partnerships are also part of the development plan to ensure that local residents have access to the employment opportunities the project will create. Did you know that this project is one of several LNG terminals being developed in the Rio Grande Valley? Together, these facilities could turn the Port of Brownsville into a global LNG hub. While the project has faced regulatory hurdles, environmental scrutiny, and community debate, construction is moving forward, and the terminal is expected to begin operations in the late 2020s. The Toyota Stadium renovation project in Frisco, Texas, represents a major investment in the future of soccer and sports entertainment in North Texas. Originally opened in 2005, the stadium has served as the home of Major League Soccer's FC Dallas and has become a cornerstone for youth and professional soccer in the region. Over the years, the venue has also hosted concerts, high school football games, and international matches. As the sport has grown in popularity across the United States, the need to modernize and expand the facility became clear. The renovation is not just about aesthetics. It's a comprehensive upgrade designed to enhance the experience for players, fans, and media alike. The centerpiece of the project is the expansion and modernization of the south end of the stadium, which now houses the National Soccer Hall of Fame. This addition brings an entirely new dimension to the venue, turning it into a year-round destination and celebrating the history of soccer in the US in an interactive and engaging way. Have you ever visited a sports stadium that doubles as a museum? That's exactly what Toyota Stadium now offers. The Hall of Fame includes immersive exhibits, virtual reality experiences, and memorabilia that trace the evolution of American soccer. For fans, it's not just a game day visit, it's an opportunity to connect with the sport on a deeper level. Beyond the Hall of Fame, the renovation includes upgraded locker rooms, state-of-the-art media facilities, and expanded seating areas. Luxury suites have been refurbished, new hospitality spaces have been added, and fan zones have been redesigned to improve flow and comfort. The renovations also improved accessibility, making the venue more inclusive for guests with disabilities. One of the key goals of the renovation was to make Toyota Stadium a more flexible, multi-purpose venue. New technology was integrated throughout the facility, including upgraded video boards, enhanced lighting systems, and improved sound equipment. These changes not only elevate the soccer experience, but also make the stadium more attractive for hosting concerts, esports tournaments, and other major events. Did you know the stadium is also deeply embedded in the youth development ecosystem? Adjacent to the main pitch are over a dozen soccer fields that serve as training grounds for the FC Dallas Academy and host regional and national youth tournaments. The renovation helps reinforce Frisco's reputation as a national hub for soccer development, with players from across the country coming to compete and train here. The project was completed with a strong focus on sustainability, using energy-efficient lighting, low-flow plumbing fixtures, and environmentally friendly building materials. These features reduce the stadium's carbon footprint and align with broader goals for greener sports infrastructure. Project Connect Light Rail in Austin is one of the most transformative public transportation efforts in the city's history. As Austin continues to experience explosive population growth, its transportation infrastructure has struggled to keep up. Traffic congestion, limited transit options, and increasing commute times have created urgent demand for an alternative. Project Connect is the city's ambitious response, a multi-billion-dollar transit system centered around a new light rail network designed to reshape how residents and visitors move across the capital of Texas. At the heart of the project is the construction of the light rail system itself. The initial phase includes 2 light rail lines, stretching roughly 10 miles, with more than 15 planned stations. These lines will connect some of the most densely populated and high-traffic areas in Austin, including downtown, the University of Texas campus, the South Congress Corridor, and the Austin-Bergstrom International Airport. The system will run both above and below ground in certain segments, incorporating a downtown tunnel that avoids street-level disruptions and increases travel speed through the city center. Have you ever seen a city plan an entire rail system with flexibility built in from the start? That's one of the most distinctive aspects of Project Connect. Rather than overcommitting to one alignment, the project was designed with scalable options, allowing the city to build out sections as funding and demand evolve. This approach ensures that the system grows in tandem with the city, rather than becoming obsolete or underutilized. The trains will be electric-powered, modern, and climate-controlled, offering a reliable, sustainable alternative to driving. With frequent service and dedicated right-of-way in most segments, the light rail is expected to dramatically reduce commute times during peak hours. It's also designed with accessibility in mind, featuring level boarding platforms, bike storage, and space for people with mobility challenges. Project Connect isn't just about trains, it's a full mobility ecosystem. In addition to light rail, the broader plan includes expanded Metro Rapid bus lines, neighborhood circulators, park and rides, and improved pedestrian and bike infrastructure. Together, these elements are designed to create a seamless network where different modes of transportation connect effortlessly. The project also emphasizes equitable access. Stations are strategically placed to serve historically underserved communities, ensuring that transit benefits reach residents who have often been left behind in previous development plans. Community input played a central role in shaping the project, from the locations of stops to considerations about displacement, affordability, and neighborhood preservation. Did you know the downtown tunnel portion will include an underground station with retail and civic space? This adds an urban design element that turns transit from just a utility into a central part of the city's culture and economy. Construction on the first phase is expected to begin soon, with full operations targeted for later in the decade. Once complete, Project Connect's light rail will not only ease congestion, but also signal Austin's shift toward becoming a more walkable, transit-friendly city, one that prioritizes long-term sustainability, economic growth, and quality of life for all residents. The Sequoia Solar Farm in Callahan County, Texas, is a major step forward in the state's continuing shift toward renewable energy. Located in the wide-open, sun-rich plains of west central Texas, the project represents both the scale and ambition that define the next generation of utility-scale solar developments. With a planned capacity of over 500 megawatts, the Sequoia Solar Farm is poised to power hundreds of thousands of homes with clean, reliable electricity while helping to diversify Texas's historically fossil fuel-dominated energy portfolio. One of the standout features of this project is its scale. Covering thousands of acres of rural land, the solar farm consists of advanced photovoltaic panels that convert sunlight directly into electricity. These panels are mounted on single-axis tracking systems, allowing them to follow the path of the sun throughout the day. This design significantly increases energy capture compared to fixed tilt systems and makes better use of the region's abundant solar resources. Have you ever wondered how much sunlight Texas gets compared to other states? Callahan County is ideally positioned for solar development, receiving well over 200 days of strong sun annually. That consistent solar exposure makes it an optimal site for a facility like Sequoia, where energy production can be both high and predictable. The Sequoia solar farm is also designed with modern grid integration in mind. It includes energy storage systems that allow excess electricity generated during peak sunlight hours to be stored and then distributed when demand is higher, such as during the early evening when solar production drops but home electricity usage peaks. These battery systems improve grid reliability and help reduce dependence on fossil fuels during those transitional periods. Another important dimension of the project is its economic impact on the local community. The construction phase brings hundreds of temporary jobs, supporting workers in everything from electrical installation to heavy equipment operation. Once operational, the facility will provide long-term maintenance and operations roles, and it will generate millions in tax revenue for Callahan County and local school districts. This financial injection can be a game changer for rural communities that often have limited sources of economic growth. Did you know solar farms like Sequoia also help landowners diversify their income? The land used for the project is typically leased from private owners, offering a steady stream of income for farmers and ranchers without fully removing the land from agricultural use. In many cases, solar installations can coexist with livestock grazing, offering a dual benefit. Environmental considerations have also played a role in the farm's planning. The site is being developed with an emphasis on preserving native vegetation and minimizing water use, especially important in drought-prone areas. Unlike coal or natural gas facilities, solar farms don't require water for cooling, making them far less resource-intensive. The Texas A&M Space Center in Houston is an ambitious initiative that aims to position Texas as a global leader in space exploration, research, and innovation. Spearheaded by the Texas A&M University System, the project is strategically located near NASA's Johnson Space Center, making it a natural extension of the region's long-standing legacy in aerospace advancement. This new center is designed to be a hub for academic collaboration, private sector partnerships, and government engagement, all focused on the future of space technology. The vision for the Texas A&M Space Center is multidimensional. At its core, the facility will serve as a research and development powerhouse, supporting advanced studies in robotics, propulsion, life sciences, and planetary exploration. Faculty and students from across the Texas A&M system will collaborate on projects that directly align with national priorities in space science and defense. The center is also expected to attract scientists, engineers, and innovators from around the world, offering state-of-the-art labs, simulation environments, and testing facilities. One of the key missions of the center is to support human spaceflight initiatives. As NASA continues its Artemis program and prepares for future manned missions to the Moon and eventually Mars, the need for external partners with academic expertise and research infrastructure is growing. The Texas A&M Space Center is designed to meet that need, serving as a research arm that can rapidly develop, prototype, and test technologies to support both government and commercial space missions. Have you ever imagined students building the next generation spacesuits or lunar robots? That's exactly the kind of work expected to happen at the Space Center. With hands-on access to high-end equipment, wind tunnels, and microgravity simulators, students won't just be studying theories, they'll be actively contributing to space missions in real time. The location in Houston is no coincidence. Proximity to NASA's mission control and established aerospace companies creates an ecosystem where collaboration and innovation thrive. Texas A&M's decision to invest in this region reinforces its commitment to driving economic growth through research and technology, particularly in sectors like aerospace, defense, and advanced manufacturing. The center will also serve as a launchpad for workforce development. New academic programs, internships, and fellowships will train the next generation of aerospace engineers, systems analysts, and space scientists. With the US space sector projected to be a $1 trillion industry within the next 2 decades, building a skilled workforce is a key priority. The Texas A&M Space Center intends to be at the forefront of that effort, creating a pipeline of talent ready to meet future demands. Did you know this center also plans to collaborate with international partners? From joint missions to student exchanges and global research projects, the facility will expand Texas A&M's reach beyond Earth, literally and figuratively. Next up, we have to talk about an $8 billion plan to save LaGuardia Airport, one of the largest airport reconstruction projects in history. Once criticized for its outdated infrastructure and passenger experience, LaGuardia is now undergoing a complete transformation. This modernization project involves constructing entirely new terminals, upgrading runways, and improving accessibility. The key components include a state-of-the-art Terminal B, a new Terminal C for Delta Airlines, and a central arrivals and departures hall that connects all terminals seamlessly. The state-of-the-art facility at LaGuardia will span 1.3 million square feet, featuring 37 gates across 4 concourses. There's also a direct-to-security luggage drop-off option. Passengers will enjoy security features, improved transportation access, additional taxiways to reduce delays, iconic public art, gourmet food offerings, and more. The restrooms have corridors behind them, so janitors can empty the trash without disturbing customers. The entrances have mosaic murals representing different parts of New York City. One of the standout features of the terminal is its aquagraphic water curtains integrated into the design of the terminal. These curtains, located on the 4th level of the arrivals and departures hall, create a mesmerizing visual experience by using 450 solenoid valves, manipulating water into precise, figurative, and abstract forms. The water ballet is synchronized with light projections and video displays, turning the airport into an artistic space for travelers. The project involves demolishing existing structures and replacing them with state-of-the-art terminals, such as the newly completed Terminal B. Modular construction methods have been used to minimize disruptions to airport operations. The new terminals feature large-span steel trusses, allowing for open, airy interiors without compromising structural integrity. A signature pedestrian bridge connecting Terminal B to 2 concourses was built using prefabricated sections. Modern baggage handling systems and smart technology have been integrated to improve efficiency and reduce wait times. The project also includes enhanced transportation links to and from the airport. The improved connections to the New York City subway system and a dedicated bus terminal make LaGuardia more accessible to travelers across the city. The new design will also focus on sustainability, with the integration of energy-efficient systems and eco-friendly materials throughout the airport. The renovation will add state-of-the-art security features, expanded concourses, and more comfortable seating areas for travelers. The new LaGuardia will be able to handle 30 million passengers annually by 2025.
Next up, we have to move over to Chile, where their solar program project is an ambitious initiative to harness the country's abundant solar energy potential. The program includes several large-scale solar power projects with a combined capacity of over 2,000 megawatts, making Chile one of the leading solar energy producers in Latin America. One of the flagship projects under the Chile solar program is the Atacama Solar Plant, located in the Atacama Desert, which is known for its high solar irradiance. The plant has a capacity of 246 megawatts and features over 776,000 solar panels spread across 1,000 hectares. The Atacama Solar Plant is capable of generating enough electricity to power approximately 200,000 homes. Construction of the Atacama Solar Plant began in 2014 and was completed in 2016. The project involved extensive planning and engineering to ensure the efficient capture and conversion of solar energy. Advanced photovoltaic technology was used to maximize energy output, and the plant's design includes features such as single-axis tracking systems that follow the sun's movement to optimize panel orientation. The Chile solar program also includes the development of the El Romero Solar Plant, which has a capacity of 246 megawatts and is one of the largest solar plants in Latin America. Located in the Vallenar region, the plant covers an area of 280 hectares and features over 800,000 solar panels. The total investment in the Chile solar program is estimated at $4 billion. The program has generated significant economic benefits, including job creation and increased investment in the renewable energy sector. The development of solar energy projects has also contributed to the diversification of Chile's energy mix, reducing reliance on fossil fuels and enhancing energy security. Let's delve into the monumental Grand Coulee Dam project, an iconic feat of engineering located on the Columbia River in Washington state. Completed in 1942, this project was a cornerstone of the New Deal, aimed at combating the economic woes of the Great Depression while harnessing the power of the mighty Columbia River. With a final price tag of $168 million, it was one of the most expensive and ambitious infrastructure projects of its time. Construction of the Grand Coulee Dam began in 1933 and required the collective effort of over 12,000 workers at its peak. These workers faced numerous challenges, including harsh weather conditions and the logistical complexities of managing such a vast construction site. The dam stretches 523 feet across and stands 550 feet tall, making it the largest concrete structure in the United States. Its creation transformed the region, providing vital hydroelectric power and irrigation that would spur agricultural and economic development. One of the most impressive aspects of the Grand Coulee Dam is its hydroelectric power capacity. Initially, it housed 3 power plants with a total generating capacity of 2,280 megawatts. Over the years, expansions have increased this capacity to over 6,800 megawatts, making it one of the largest power producers in the world. The dam also created Lake Roosevelt, a reservoir that spans approximately 125 square miles. This reservoir provides irrigation to over 600,000 acres of farmland, transforming arid regions into fertile agricultural lands. The agricultural productivity of central Washington owes much to the water resources provided by the Grand Coulee Dam. However, the construction of the dam was not without its controversies and challenges. It necessitated the relocation of thousands of people and had significant environmental impacts, particularly on fish populations and the livelihoods of indigenous tribes. The project's success required innovative engineering solutions, such as the use of massive cableways to transport concrete and materials across the site and careful management of the Columbia River's flow. It's time.
But how about one of the busiest bridges in the world? Constructed between 1927 and 1931, the George Washington Bridge was designed by Swiss-American engineer Othmar Ammann, who utilized innovative techniques to create what was then the largest suspension bridge in the world. The bridge's main span, which measures 3,500 feet, was a record-breaking achievement at the time of its completion. The bridge's design includes 2 main cables, each 36.5 inches in diameter, made up of around 26,000 individual wires bound together. These cables were manufactured and spun on-site using the saddle method, which involved spinning the wires from one anchorage over the tower tops and down to the other anchorage. This method allowed for precise tensioning of the cables and was crucial for the bridge's structural integrity. The bridge's 2 towers, each standing 604 feet tall, are composed of steel and rest on massive concrete foundations anchored into the bedrock beneath the river. The towers were initially designed to be clad in granite, but due to the economic constraints of the Great Depression, they were left as exposed steel, which has become an iconic feature of the bridge. The open steel lattice structure of the towers not only provides the necessary strength, but also reduces wind resistance, which is vital for the stability of such a large suspension bridge. The construction of the bridge required significant feats of engineering and logistics. Workers built caissons on the riverbed to serve as foundations for the towers. They were sunk to depths of up to 80 feet below the water level and filled with concrete to provide a stable base for the towers. Building the caissons was one of the most challenging parts of the construction, requiring deep excavation and precise engineering to ensure stability. The bridge's deck was initially designed to carry 6 lanes of traffic, but due to the structure's robustness and foresight in design, a second deck was added in 1962, increasing the total capacity to 14 lanes. This lower deck, known as Martha, was added without interrupting the flow of traffic on the upper deck, a significant engineering accomplishment that showcased the bridge's adaptability and demands forward-thinking design. The George Washington Bridge was completed ahead of schedule and under budget, which is a testament to the efficiency and skill of Aman and his team. It opened to traffic on October 24, 19, and has since become a vital transportation link, handling more than 100 million vehicles annually.
Let's move over to New York for the gigantic 2nd Avenue subway project. This heavily delayed development is now a reality that significantly enhances public transit in New York City. With a price tag of over $4.5 billion for its first phase alone, this project is among the most ambitious and expensive transit ventures in America. The 2nd Avenue subway has been on the drawing board since the 1920s. Financial challenges, political hurdles, and engineering complexities repeatedly stalled the project. After decades of setbacks, Phase 1 finally opened in January 2017. This marked the first major expansion of the subway system in New York City in over 50 years. The initial phase added 3 new stations along 2nd Avenue at 72nd, 86th, and 96th Streets. It has extended the Q train to provide service to the Upper East Side. These stations are state-of-the-art, featuring spacious platforms, elevators, escalators, and vibrant artwork. This makes them some of the most visually appealing ones in the system. The 2nd Avenue subway is far from complete. Phase 2, with an estimated cost of $6 billion. This will extend the line north to Harlem, adding 3 more stations at 106th, 116th, and 125th Streets. Additional phases will eventually stretch the line down to Hanover Square in Lower Manhattan. The proposed full line would be 8.5 miles and 16 stations long, serve a projected 560,000 daily riders, and cost more than $17 billion. This project has dramatically reduced congestion on the overcrowded Lexington Avenue line. This was previously the only subway serving the area. It has also improved connectivity for Upper East Side residents, cutting travel times and boosting property values in the neighborhood. The subway has boosted economic development along 2nd Avenue, attracting new businesses, residential projects, and retail establishments. It has also improved accessibility for low-income and minority communities in East Harlem, addressing long-standing inequities in transit service. Despite its successes, the 2nd Avenue subway has faced criticism for its high costs, delays, and limited scope. Each phase has taken years to plan and build, raising questions about the efficiency of large-scale transit projects in the US. In coming years, the 2nd Avenue subway will continue to transform the transit network in New York City.
But what about the redevelopment of an entire train station? That's what happened with New York's Moynihan Train Hall. This grand project, completed in January 2021, seamlessly blends state-of-the-art facilities with historic architectural elements. The project cost approximately $1.6 billion, a strategic investment aimed at reviving the Midtown area and providing New York commuters and travelers with a more dignified and spacious environment. Construction of the train hall was a logistical challenge, requiring the coordination of thousands of workers in a densely populated urban area. The workforce fluctuated throughout the project, peaking at around 1,200 workers during its most intense phases. These individuals were involved in intricate tasks ranging from restoring the century-old steel trusses to integrating modern technology and security systems within the structure. The Moynihan Train Hall solves several pressing problems associated with the original Penn station: overcrowding, lack of natural light, and limited amenities. By expanding into the Farley building, the project has effectively increased the station's total footprint, allowing it to serve up to 700,000 passengers daily. The hall's design features a dramatic 92-foot-high skylight that arches over the main concourse. This skylight, covering an area of 31,000 square feet, not only illuminates the space with natural light, but also serves as a modern counterpoint to the Farley building's Beaux Arts facade.
Next, we have to talk about the incredible Central Park Tower, soaring 1,550 feet above New York City. This tower holds the title of the tallest residential building in the world. Located on Billionaires Row along West 57th Street, this architectural marvel represents luxury and engineering mastery. Completed in 2020, it redefines urban living while contributing to the iconic Manhattan skyline. Its construction began in 2014 with the goal of combining cutting-edge engineering with luxury. The prime location of the tower offers unparalleled views of Central Park and beyond, making it a coveted address for the world's elite. With a total cost of approximately $3 billion, the building houses 179 ultra-luxurious residences, including a triplex penthouse, along with premium commercial spaces. Residents enjoy access to the Central Park Club, a 3-story private club featuring a ballroom, outdoor terrace, and a 60-foot swimming pool. Other amenities include a state-of-the-art fitness center, private dining spaces, and unparalleled views of Central Park. While luxury is its hallmark, Central Park Tower incorporates sustainable features. High-performance glass reduces energy consumption by optimizing natural light while minimizing heat gain. Efficient HVAC systems and LED lighting further enhance energy efficiency. Central Park Tower stands 98 stories tall with a unique cantilever design that extends over neighboring structures to maximize views. The exterior features a sleek curtain wall facade made of reflective glass and stainless steel, enhancing its modern aesthetic. The structure employs a concrete and steel core to ensure stability and withstand high wind pressures, a necessity for super tall skyscrapers. Advanced damping systems minimize swaying, ensuring comfort for residents on higher floors. The interiors of the tower reflect sophistication, with premium materials like marble, custom woodwork, and high-end fixtures. Residents also enjoy exclusive amenities spread across 5,000 square feet, including a private club, fitness center, spa, and a 60-foot indoor pool. Building a skyscraper of this scale posed significant challenges, including navigating strict zoning regulations in New York and coordinating complex logistics in a densely populated area. Modular construction techniques and a high-strength concrete mix were employed to expedite the process. Workers meticulously assembled the cantilevered sections of the building to ensure structural integrity without compromising aesthetic appeal.
Let's investigate the Gas Aductto Del Sur next. This is a major infrastructure project designed to transport natural gas from Venezuela to Argentina, passing through Brazil. This ambitious project aims to enhance regional energy integration and provide a reliable supply of natural gas to support economic growth and development in South America. Construction of the Gas Aductto Del Sur began in 2015, with the project expected to span approximately 5,000 miles. The pipeline is designed to transport up to 50 million cubic meters of natural gas per day, providing a crucial energy source for industrial, commercial, and residential use. The pipeline will connect key natural gas fields in Venezuela with major consumption centers in Brazil and Argentina, enhancing energy security and reducing reliance on imported fuels. One of the significant engineering challenges of the Gas Aductto Del Sur is the diverse terrain it traverses. The pipeline route includes dense forests, mountainous regions, and river crossings, requiring advanced engineering solutions and extensive environmental assessments. The project incorporates state-of-the-art technology for pipeline construction and monitoring, ensuring the safety and reliability of the gas supply. The total cost of the Grand Gas Aductto del Sur is estimated at $23 billion. The project is expected to generate substantial economic benefits, including job creation, increased energy supply, and enhanced regional cooperation. Environmental and social considerations are integral to the Grand Gas Aductto del Sur project. Comprehensive environmental impact assessments were conducted to minimize the impact on local ecosystems and communities. The project includes measures to protect biodiversity, manage water resources, and engage with local communities to address their concerns and ensure their participation in the project's benefits. Let's travel over to the next megaproject, the Los Angeles County Metro Purple Line Extension, which is a massive $9.3 billion rail project that's stretching the definition of urban transit development. Extending the Metro Purple Line by 9 miles, this project is not just about adding tracks. It's about seamlessly connecting key sectors of the city, from the skyscrapers of downtown LA to the vaunted gates of the University of California. Slated for completion in 2027, the Purple Line extension is currently a hive of activity with over 5,000 workers bustling daily. Building a subway in an area prone to earthquakes demands cutting-edge construction techniques. The team employs advanced tunneling methods, including earth pressure balance machines that delicately burrow beneath the city, ensuring minimal disruption to the surface life and structural integrity of the buildings above. This project solves critical transportation problems in one of America's most congested cities by offering a reliable, high-speed alternative to road travel, effectively reducing traffic and the city's carbon footprint. Once operational, it's expected to serve about 4,900 citizens and riders daily. Comparing this to the scale of other megaprojects around the globe, the Purple Line extension's budget overshadows the construction costs of the new Wembley Stadium in London, illustrating the monumental investment in public infrastructure and the future of Los Angeles. The project's integration of smart technology systems for maintenance and operation sets new standards for public transportation. Next,
it's time to move over to Utah for the Salt Lake City International Airport redevelopment. Initiated in 2014, the project involves a complete overhaul of the existing facilities, including the construction of a new terminal and concourses, all aimed at modernizing the airport to handle increasing passenger demands and improving seismic resilience. The construction of the new terminal and concourses, involving several major contractors, is characterized by significant engineering challenges and innovative solutions. The first phase of the project, completed in 2020, included the construction of a 900,000 square foot terminal and the west portions of 2 linear concourses. This phase introduced 45 new gates and a 3,600 vehicle parking garage, representing the largest public works project in Utah's history. A critical aspect of the construction was addressing the seismic risk, given the airport's proximity to the Wasatch Fault, an active seismic zone. To ensure the structural integrity of the new facilities, engineers installed 1,020 steel piles to support the foundations, ensuring the building could withstand potential earthquakes. These piles, driven deep into the ground, provide a stable base for the large terminal structures, which feature a 3-level design with expansive use of steel and concrete. The new terminal's design emphasizes both functionality and aesthetics, with the use of high-performance glazing and large open spaces that draw natural light into the building. This not only creates a welcoming environment for passengers, but also helps reduce energy consumption. The building's layout, with elevated roadways and separate levels of arriving and departing passengers, enhances traffic flow and minimizes congestion. Another significant feature of the project is the 7-mile-long baggage handling system, one of the most advanced in the country. This system, designed to efficiently manage the high volume of passenger baggage, includes large radius turns and wide conveyor belts, capable of handling oversized items like skis and golf clubs. The system is equipped with automated screening capabilities, reducing manual handling and enhancing the overall efficiency of airport operations. The construction of the new parking garage, which doubles the capacity of the previous facility, involved significant structural work. The garage was built using 90,000 cubic yards of concrete and 9,000 tons of rebar, ensuring its durability and capacity to accommodate the increased traffic expected with the airport's expansion.
We don't have to travel far for the Penn Station Access Project, which is a transformative initiative aimed at improving rail connectivity in New York City. Spearheaded by the MTA, this $2.87 billion project will expand access to Penn Station. More than 600,000 passengers use the station on an average weekday, or up to 1,000 every 90 seconds. It is the busiest passenger transportation facility in the United States and in North America. The project will bring 4 new Metro North Railroad stations to the Bronx: Hunts Point, Parkchester, Van Nest, Morris Park, and Co-op City. These stations will connect directly to Penn Station, reducing travel times and offering a convenient alternative to crowded roadways. By 2027, commuters will have a seamless link between the Bronx and Manhattan, cutting up to 75 minutes off daily commutes. To support this enhanced service, 19 miles of Hellgate Line in Amtrak are being upgraded. This includes track rehabilitation, modernized signals, and updated power and communication systems. Reconfigured interlockings will improve train routing and increase the reliability of both Metro North and Amtrak services. Construction began in December 2022 and is progressing steadily. Long-term single-track outages have allowed crews to work efficiently, improving safety and productivity. Key milestones include the commissioning of the Leggett interlocking in 2024, a crucial component that will enhance operational flexibility. Throughout the construction, public meetings are being held to keep communities informed of progress and upcoming phases. The Penn Station Access Project is expected to drive economic growth in the East Bronx. With 4 new stations, the area will see increased property values, job opportunities, and business development. By improving public transit, the project is all set to reduce traffic congestion and lower air pollution. Fewer cars on the road mean a cleaner environment and more sustainable urban living. The benefits of this project extend far beyond the Bronx. A new one-seat ride between Penn Station and the East Bronx, Westchester, and Connecticut will improve connectivity across the region. The project introduces a second Metro North route into Manhattan, providing an alternative to Grand Central Terminal. This added capacity will support the growing demand for rail service in one of the busiest corridors in the country.
But what about a massive dam megaproject? For that, we have to travel to the Ohio River, where the Olmstead Locks and Dam project is located. This monumental undertaking, designed to replace aging infrastructure and modernize the waterway system, is crucial for the transportation of billions of dollars worth of goods annually across Central States. This project, which officially completed in 2018 after over 30 years of planning and construction, spans across the river and involved an extraordinary financial investment of approximately $3 billion. The construction required the sustained effort of hundreds of engineers, technicians, and laborers over several decades, underscoring the project's scale and complexity. The Olmstead project replaced 2 older and less efficient facilities, Locks and Dams 52 and 53, which had become increasingly unreliable, causing significant delays in river traffic and logistical inefficiencies. The new structure consists of a navigational pass and 2 parallel 110-foot by 200-foot locks. This setup significantly eases the river traffic, allowing for the smooth passage of approximately 90 million tons of cargo yearly. One of the notable challenges of the Olmstead Locks and Dam was its innovative construction method, specifically the use of in-the-wet technology. Unlike traditional dry dock methods, this technique involves assembling large modular sections of the dam on land, then floating them to their installation site on the river. The total amount of concrete used in the dam's construction would be enough to pave a sidewalk stretching from New York to San Francisco. A special feature of the Olmstead Locks and Dam is its resilience to seismic activity. The region is near the New Madrid fault line, and as such, the structure was designed to withstand significant earthquakes, ensuring the long-term stability and safety of this critical infrastructure. The project's importance extends beyond just its immediate functionality. By improving the reliability and efficiency of the Ohio River as a navigational channel, the Olmstead Locks and Dam also bolsters the economic viability of river transportation, which is significantly more fuel efficient and environmentally friendly compared to road and rail transport.
The Governor Mario M. Cuomo Bridge, which replaced the aging Tappan Zee Bridge, is one of the most significant bridge projects in the history of New York. Costing $4 billion, this twin-span cable-stayed bridge stretches 3.1 miles across the Hudson River, connecting Rockland and Westchester counties. Completed in 2018, it represents a triumph of modern engineering and infrastructure innovation. The bridge features 2 spans, each supporting 8 lanes of traffic with a shared pedestrian and bike path, offering scenic views of the Hudson River. Its design includes sleek cable-stayed towers, which not only enhance its aesthetic appeal, but also provide structural efficiency. The lighting system incorporates energy-efficient LEDs that illuminate the bridge in vibrant colors for special occasions. Additionally, the bridge is equipped with state-of-the-art monitoring systems to ensure structural health and safety. Building the Cuomo Bridge required innovative methods to minimize environmental and community impact. Engineers employed precast concrete sections, which were manufactured off-site and transported to the construction area, reducing on-site work and improving efficiency. The foundation consists of large-diameter steel piles driven deep into the riverbed to anchor the bridge securely. To accelerate the construction timeline, a custom-built floating crane, nicknamed iLift NY, was used to lift massive bridge components into place. The project emphasized sustainability, incorporating durable materials to extend the bridge's lifespan to 100 years. The bridge's design reduces maintenance needs, and its LED lighting system is energy efficient. Special care was taken to protect the Hudson River's ecosystem during construction, including the creation of artificial habitats for fish. The Cuomo Bridge has improved traffic flow for 135,000 daily vehicles, reducing congestion and enhancing safety. It has also revitalized the regional economy by creating thousands of construction jobs and stimulating local businesses. The pedestrian and bike path further enhances community access and promotes eco-friendly transportation. While the bridge is celebrated as an engineering feat, it faced criticism for its high cost and project delays. Despite these challenges, it stands as a vital link for the transportation network in New York.
It's time to talk about the Aqui Superport, located in São João da Barra, Brazil. This deep water port is designed to handle a wide range of cargo, including oil, iron ore, and containerized goods, providing a critical gateway for Brazil's exports and imports. Construction of the Aqui Superport began in 2017, and the project was completed in phases, with full operational capacity achieved in 2015. The port complex covers an area of approximately 130 square miles and features multiple terminals, including a dedicated oil terminal, an iron ore terminal, and a container terminal. The port's deep water berths can accommodate some of the largest vessels in the world, including very large crude carriers and Capesize bulk carriers. One of the significant engineering challenges of the Aqui Superport project was the construction of the port's extensive infrastructure. This included the dredging of deep water channels, the construction of breakwaters, and the development of onshore facilities such as storage tanks and conveyor systems. The project also involved the installation of advanced navigation and safety systems to ensure the safe and efficient movement of vessels. The price tag of this immense undertaking is $2.5 billion. The port has generated significant economic benefits, including increased trade, job creation, and the development of associated industries such as logistics and manufacturing. Next up, we have to discuss one of the most expensive megaprojects in the world, called the Hanford Nuclear Reservation Cleanup. Situated in Washington State, the Hanford site was once home to the largest plutonium production facility in the United States, playing a pivotal role during World War II and the Cold War. However, decades of nuclear production have left a legacy of contamination, necessitating an extensive cleanup effort with costs estimated to range between $300 billion and $600 billion. The Hanford Nuclear Reservation spans 586 square miles and includes 9 decommissioned nuclear reactors and numerous processing facilities. The cleanup project, managed by the U.S. Department of Energy, officially began in 1989 following the site's designation as a Superfund site by the Environmental Protection Agency. One of the primary challenges of the Hanford cleanup is dealing with the vast quantities of radioactive waste stored in underground tanks. These tanks, some of which are over 70 years old, have been found to leak, posing a significant threat to the surrounding environment. A critical component of the cleanup is the construction and operation of the waste treatment and immobilization plant, also known as the vitrification plant. This facility aims to convert radioactive waste into a stable glass formed through a process known as vitrification. By immobilizing the waste in glass, the long-term risk of environmental contamination is significantly reduced. The plant is one of the most complex and expensive construction projects at Hanford, with an estimated cost of $17 billion. The cleanup efforts at Hanford also involve the remediation of contaminated soil and groundwater. Advanced technologies and methods, such as pump and treat systems, are employed to remove radioactive contaminants from groundwater and prevent their migration. The project has faced numerous challenges, including technical difficulties, regulatory hurdles, and budget constraints. Despite these challenges, significant progress has been made in reducing immediate risks and advancing long-term remediation goals. Comparatively, the Hanford cleanup is unparalleled in its scope and complexity, reflecting the immense legacy of the United States nuclear weapons program. The project's costs and duration are unprecedented, with estimates suggesting the cleanup could continue for several more decades.
It's time to move over to the state of Illinois now to talk about the St. Regis Chicago skyscraper project, formerly known as Vista Tower. It's the third largest building in Chicago, standing at 1,198 feet tall with 101 stories. The construction of this mixed-use skyscraper, which includes residential units, a hotel, and luxury amenities, presents numerous engineering challenges that required innovative solutions. The construction of the St. Regis Chicago began in 2016 and was completed in 2020. Designed by the renowned architect Jean Gang, the tower's distinctive design features three interconnected towers of varying heights, arranged in a staggering formation. This configuration not only creates a unique visual profile, but also plays a crucial role in the building's structural stability. One of the challenges was addressing the wind loads on the tall, slender structure. To mitigate these effects, the design includes a blow-through floor at the 83rd level. This open-air section allows wind to pass through the building, reducing wind-induced sway and improving overall stability. The use of this feature is a relatively new approach in skyscraper design and highlights the innovative engineering applied to the project. The building's core structure is composed of reinforced concrete, which provides the necessary strength to support the high-rise while allowing for flexibility under stress. The concrete core houses the building's elevators and utilities and is surrounded by steel frames that support the external cladding and the floor slabs. The use of high-strength concrete and advanced reinforcement techniques is essential in achieving the building's height and slender profile without compromising safety. The construction also involves significant logistical planning, particularly given the tower's location in the dense urban environment of Chicago's Lakeshore East neighborhood. The site's proximity to other high-rise buildings and active roadways required meticulous coordination to manage material deliveries, crane operations, and worker safety. The tower was constructed using a combination of traditional building techniques and modular construction, where certain components were prefabricated off-site and assembled on-site. This approach helped to accelerate the construction timeline and reduce the impact of the surrounding area. The St. Regis Chicago also features extensive underground construction, including a 6-level basement that houses parking facilities, mechanical rooms, and storage areas. Constructing these underground levels involved deep excavation and the installation of a complex foundation system designed to handle the significant loads of the skyscraper above.
The Texas high-speed rail is a bold step toward revolutionizing transportation in the United States. Connecting Dallas and Houston, this $30 billion project aims to bring Japanese Shinkansen technology to the Lone Star State. This offers a 90-minute journey between two of the fastest-growing cities in the nation. With trains traveling at speeds up to 205 miles per hour, it promises to halve travel times and provide a sustainable alternative to congested highways and overcrowded airports. The route spans 240 miles, starting in Dallas and running through Grimes County before reaching Houston. 3 state-of-the-art stations are planned. The Dallas station will be located in the Cedars District, close to major highways and the K. Hutchison Convention Center. The Brazos Valley Station in Grimes County will connect to Texas A&M University, stimulating local economic development. In Houston, the station will rise at the former Northwest Mall site, offering easy access to the energy corridor and other business hubs. The technology driving this project is the Japanese Shinkansen system, renowned for its safety and reliability. Since its induction in 1964, the Shinkansen has achieved an unbelievable record, with 0 passenger fatalities due to accidents. Texas Central, the private company behind the project, plans to use this proven model, adapted to American needs. The trains will feature wide aisles, fast Wi-Fi, and smooth, frequent services, running every 30 minutes at peak times. Construction of the rail line is expected to leverage advanced engineering and machinery. High-capacity cranes, specialized rail-laying machines, and advanced tunneling equipment will be employed to ensure precision and speed. The relatively flat terrain between Dallas and Houston minimizes the need for extensive tunneling or complex infrastructure. This makes the route ideal for high-speed rail. Despite this, the project has faced challenges, including opposition from landowners and questions about financing. Texas is uniquely suited for high-speed rail. With a population of over 29 million and a GDP exceeding $2 trillion, the growing economy and urban expansion of the state create a strong demand for efficient transportation. Dallas and Houston, home to nearly 20 million people combined, are economic powerhouses. The project could eventually expand to include cities like Austin and San Antonio, further increasing its reach and utility. The benefits of the Texas high-speed rail extend beyond convenience. By reducing car and air travel, the project aims to cut greenhouse gas emissions and alleviate road congestion. It's estimated to create 10,000 construction jobs annually and 1,500 permanent jobs once operational. Moreover, it could serve as a model for other high-speed rail projects across the US. This is sparking a new era of sustainable infrastructure. Despite setbacks and uncertainties, the Texas high-speed rail holds immense potential. If successful, it will redefine how Americans travel, combining speed, sustainability, and innovation. While the road ahead is challenging, the vision of a connected, efficient future keeps the project moving forward. The early 2030s could mark the dawn of high-speed rail in America, with Texas leading the charge.
We have to talk about the 2nd Avenue Subway Megaproject next, located in New York City. Officially part of the Metropolitan Transportation Authority network, this new subway line runs along 2nd Avenue on the east side of Manhattan. The project has been in the conceptual and developmental stages since 1920, but saw its first phase completed and opened to the public on January 1, 2017. Phase 1 of the 2nd Avenue subway cost approximately $4.45 billion and included 3 new stations with a new terminal at 96th Street. The construction of the 2nd Avenue subway involved approximately 6,000 workers at various stages, tackling complex urban engineering challenges such as tunneling beneath densely populated areas and avoiding disruptions to the existing utility infrastructures. This necessitated the use of tunnel boring machines, which are sophisticated pieces of equipment that can efficiently cut through New York's bedrock while minimizing vibrations that could damage building foundations above. The 2nd Avenue subway covers a planned total length of 8.5 miles once all phases are complete. To put the scale of this project into perspective, the total length of the new subway line would be equivalent to more than 146 football fields laid end to end. Each station is built with expansive, column-free platforms and high ceilings to enhance passenger comfort and safety, a notable departure from many of the city's older subway stations. The 2nd Avenue subway has faced numerous challenges, including budget overruns and delays primarily due to the complexities of constructing a new subway line in one of the world's most built-up urban environments. Comparatively, the cost and scope of the 2nd Avenue subway are similar to those of the Crossrail project in London, although the latter is even larger in scale.
Let's move over to the One Vanderbilt, which was completed in 2020 and redefined the New York City skyline as a towering example of engineering brilliance. Located adjacent to Grand Central Terminal, this $3.3 billion skyscraper is a symbol of innovation and sustainability, merging functionality with breathtaking design. The project was conceived in 2010 as part of Midtown East's rezoning plan, aimed at revitalizing the area. Construction began in 2016, with the goal of creating a state-of-the-art commercial hub that integrates seamlessly with public transit systems. One Vanderbilt stands at 1,401 feet, making it the fourth tallest building in New York City. It offers 1.7 million square feet of office space spread over 58 stories, designed to accommodate thousands of workers. The tower features Summit 1 Vanderbilt, an immersive observation deck at 10 feet, providing panoramic views of the city. Advanced elevator systems reduce wait times, enhancing efficiency. The construction of 1 Vanderbilt presented significant challenges due to its proximity to Grand Central Terminal. Engineers had to ensure the tower's foundation did not disrupt the historic infrastructure beneath. To achieve this, they used drilled caissons to transfer the building's weight deep into the bedrock, ensuring stability. The structure incorporates a steel and concrete hybrid frame, providing the strength needed to withstand wind forces at such heights. Engineers also designed the building with tapered setbacks, reducing wind loads and giving the tower its iconic shape. A tuned mass damper, weighing hundreds of tons, is installed near the top to counteract swaying and enhance comfort for occupants. Modular construction accelerated timelines while maintaining quality. Its glass curtain wall facade minimizes heat gain while maximizing natural light, contributing to energy efficiency. Integration with Grand Central Terminal involved building a direct transit connection, allowing seamless access to subway and commuter trains. This made 1 Vanderbilt a central transit-oriented development. The $3.3 billion project not only transformed Midtown Manhattan, but also generated thousands of construction jobs.
We travel over to Chile next, where the Chacao Channel Bridge is located. This project, once completed, will significantly improve transportation and economic integration between the island and the mainland. Construction of the Chacao Channel Bridge began in 2018, and the project is expected to be completed by 2025. The bridge will span approximately 1.7 miles across the Chacao Channel, featuring a central suspension span of 350 feet, making it one of the longest suspension bridges in the world. The bridge will have 2 main pylons, each rising about 656 feet above the water, supporting the central span with massive steel cables. One of the critical challenges of the Chacao Channel Bridge project is the harsh environmental conditions of the Chacao Channel. The area is known for strong winds, powerful tides, and seismic activity, all of which pose significant engineering challenges. The bridge is designed to withstand these conditions, incorporating advanced materials and construction techniques to ensure its durability and safety. The bridge will accommodate both vehicular and pedestrian traffic, with 2 lanes in each direction and dedicated pathways for pedestrians and cyclists. This infrastructure will replace the current ferry system, which is often subject to delays and weather-related disruptions, providing a more reliable and efficient transportation link. The project is estimated to cost around $740 million, with funding sourced from both the Chilean government and international investors. The economic benefits of the bridge are expected to be substantial, including increased tourism, reduced transportation costs, and enhanced economic integration between Chiloé Island and the mainland. Next time to discuss the next megaproject. Welcome to the Treasure Island redevelopment in San Francisco. Set on a man-made island in the heart of San Francisco Bay, this project is transforming a former naval base into a vibrant residential and commercial hub. Treasure Island spans approximately 405 acres. To put that into perspective, it's roughly the size of 300 football fields laid side by side. The project's budget is a whopping $6 billion, earmarked for creating over 8,000 homes, of which a quarter are designated as affordable housing. The plan includes schools, hotels, and over 300 acres of parks, which means green space is central to the island's new identity. Construction began in 2011 and is set to continue in phases through 2035. The scale of manpower and machinery on this site is staggering. At its peak, the project employed thousands of workers, each skilled in various aspects of construction, from engineers and architects to builders and landscapers, all converging to bring this vision to life. One of the most intriguing aspects of the Treasure Island redevelopment is its commitment to sustainability. The island is poised to become one of the most eco-friendly developments in the U.S. with advanced stormwater systems, zero-waste goals, and buildings designed to lead gold standards. But it hasn't been all smooth sailing. The project has faced its share of challenges, from concerns over rising sea levels to remediation of the soil, which was contaminated during its days as a naval base. These issues required innovative solutions such as elevated land to combat potential flooding and extensive cleanup efforts to ensure the safety and sustainability of the new community. The amount of soil moved and treated for the redevelopment could fill over 60 Olympic-sized swimming pools. And if we talk about the infrastructure, the main roadway spanning the island's length is akin to laying down nearly 3 Golden Gate bridges end-to-end. Next up,
let's navigate the stunning Frederick Douglass Memorial Bridge. Located in Washington, D.C., this iconic infrastructure project is designed to replace the aging South Capitol Street Bridge, which had become functionally obsolete. Construction of the new bridge began in 2018 and was completed in 2021. This project represents one of the largest infrastructure investments in the history of the District of Columbia, with the bridge spanning 1,600 feet across the Anacostia River and featuring 3 prominent arch structures that define its aesthetic and structural integrity. The bridge's design includes 6 traffic lanes, as well as dedicated paths for bicycles and pedestrians, providing enhanced multimodal transportation options. The structure is supported by massive piers sunk deep into the riverbed, ensuring stability and resilience against the forces of the river and the dynamic urban environment. One of the key engineering challenges of the Frederick Douglass Memorial Bridge was constructing its large, sweeping arches. These arches are made from high-strength steel and were assembled on-site using precise construction techniques to ensure their alignment and structural performance. Each arch was constructed in segments, lifted into place by cranes and carefully connected. The assembly required detailed planning and execution to manage the complex geometry and the loads transferred through the arches into the foundation piers. Another critical aspect of the bridge's construction involved the use of modern materials and methods to extend the lifespan of the structure and minimize maintenance needs. The bridge deck is supported by a system of cables anchored at the top of arches and connected to the deck, which helps to evenly distribute the load across the structure. These stay cables are tensioned to provide the necessary support, while allowing for flexibility and movement under traffic loads and thermal expansion. The foundation work was particularly challenging due to the bridge's location over the Anacostia River. The construction team employed cofferdams, temporary waterways enclosures pumped dry to create a dry work environment below the waterline. These cofferdams allowed workers to excavate and install deep foundations that anchor the bridge piers securely into the riverbed. Additionally, the construction process had to consider the tidal nature of the river and the varying water levels. The bridge also incorporates advanced drainage and stormwater management systems to handle runoff from the roadway. These systems are designed to reduce the environmental impact on the Anacostia River by capturing and treating stormwater before it enters the waterway.
But the Hudson Tunnel project is arguably even more impressive, which will upgrade some of the most critical infrastructure in America. Beneath the Hudson River lies a vital rail connection between New York and New Jersey. This connection serves over 200,000 daily commuters, making it a lifeline for the Northeast Corridor. The project, part of the Gateway program, aims to modernize these aging tunnels and secure the future of rail travel. The first component is the construction of a new 2-track tunnel. This tunnel will run from the Bergen Palisades in New Jersey to Manhattan. It is designed to add capacity and create redundancy in the system. The second component involves the final phase of the Hudson Yards concrete casing. This section will ensure uninterrupted rail access to Penn Station. The third component is the rehabilitation of the existing North River Tunnel. This tunnel, damaged during Superstorm Sandy in 2012, will be restored to modern standards. Construction is a massive undertaking, involving advanced machinery and precise engineering. Tunnel boring machines will carve through the dense rock beneath the Hudson River. High-capacity cranes will assist in laying massive concrete segments for the tunnels. Specialized rail laying machines will ensure smooth track installation. This process ensures the tunnels are built to withstand modern demands and extreme weather. The new tunnel is set for completion before the rehabilitation of the existing one begins. This strategy minimizes disruptions while maintaining service for commuters. By 2035, the project aims to provide 4 fully operational tracks beneath the Hudson River. The benefits are transformative. The project will eliminate a single point of failure in the rail network. It will create over 95,000 jobs during construction, boosting the local economy. An estimated $19.6 billion in economic activity will be generated throughout the project's life cycle. The new system will also reduce road congestion, cutting greenhouse gas emissions by 2 million tons annually. This is the equivalent of flying 2.6 million people from New York to San Francisco. The Pennsylvania Railroad began design and construction work of the existing North River Tunnel in February 1903. It was opened to revenue service in November 1910. The 2-track North River Tunnel was state-of-the-art in the early 20th century. However, its age and design limitations now hinder reliability. In 2012, Superstorm Sandy worsened these issues, flooding the tunnel and causing lasting damage. The Hudson Tunnel project addresses these challenges, ensuring safe and efficient travel for generations.
But what about one of the tallest skyscrapers in New York City? Located in the bustling Hudson Yards district of Manhattan, the Spiral Tower stands as a pinnacle of architectural innovation and modern design. Officially known as 66 Hudson Boulevard, this towering skyscraper reached its completion in 2022, emerging as one of the most distinctive profiles against the Knicks skyline due to its spiraling green terraces that ascend with the building's rise. The spiral spans 65 stories, measuring approximately 141 feet in height. The project carried a substantial financial commitment, with development cost estimated at around $3.7 billion. The construction of the spiral employed approximately 7,600 workers across various phases, reflecting its scale and the complexity of its design. This architectural marvel was conceived to offer a blend of premium office spaces and expansive green outdoor terraces on each floor, integrating nature into the urban workspace. Each terrace is equipped with foliage and seating areas, providing accessible outdoor space to office occupants, a rare feature in Manhattan's dense urban landscape. The construction of the spiral involved innovative building techniques, particularly in the integration of its steel superstructure with the cascading terraces. Advanced computer modeling and precision fabrication were crucial to ensuring that each floor's outdoor space seamlessly aligns with the spiraling design. The spiral's total floor area is about 2.8 million square feet, roughly equivalent to the size of 50 football fields. However, the project wasn't without challenges. Its construction phase coincided with a pandemic, which posed significant logistical challenges, delaying materials and reducing workforce efficiency due to health and safety protocols. Yet, the project team adapted with enhanced safety measures and scheduling adjustments to mitigate these impacts.
Let's travel over to the Hudson Tunnel project, a $16 billion undertaking that seeks to transform rail infrastructure between New York and New Jersey. This project is critical to modernizing the Northeast Corridor, the most heavily traveled rail line in the United States. Once completed, it will ensure seamless transit for Amtrak and New Jersey Transit passengers, improving reliability and safeguarding operations against future natural disasters. The existing North River Tunnel, built over a century ago, suffered severe damage during Superstorm Sandy in 2012. The storm left behind structural weaknesses, necessitating urgent rehabilitation. The NRT serves as the single passenger rail link between Manhattan and the western US, connecting Washington, D.C. to Boston. Without upgrades, the tunnel bottleneck risks a daily $100 million economic impact, reflecting the 20% contribution of the Northeast Corridor to the national economy. The project involves building a 2.4-mile double-track tunnel beneath the Hudson River, stretching from Bergen Palisades in New Jersey to Manhattan. Central to its scope is the rehabilitation of the North River Tunnel, addressing extensive structural and flood damage sustained over the years. Then, a concrete casing at Hudson Yards will ensure a seamless connection to Penn Station, integrating the new infrastructure into the existing rail network. To safeguard rail operations from future extreme weather events, new floodgates will be installed, providing enhanced protection against rising waters. The tunnel will incorporate state-of-the-art engineering with advanced flood resilience measures. This includes a robust drainage system, climate-resistant materials, and modern ventilation for improved air quality. The construction utilizes state-of-the-art engineering technologies to address the unique challenges of tunneling beneath a riverbed. Tunnel boring machines excavate the 2.4-mile route, ensuring precise tunneling through dense geological formations. These massive machines carve through rock and soil while simultaneously installing precast concrete tunnel linings, providing immediate structural support. Advanced geotechnical monitoring systems track ground stability in real time, minimizing risks during construction. Meanwhile, robotic systems streamline the application of waterproofing membranes, ensuring the tunnel remains impervious to leaks. Scheduled for phased completion, the new tunnel is expected to open in 2035, with the rehabilitated NRT operational by 2038. Once completed, the Hudson Tunnel project will transform rail travel, accommodating nearly 200,000 passengers daily. The project is expected to create 72,000 new jobs and $19 billion in economic activity. But this is just one of the smaller mega projects on our list.
Let's travel over to Sao Paulo, one of the largest and most populous cities in Brazil. They are enhancing its public transportation infrastructure with the Sao Paulo Metro Line 6. Often referred to as the Orange Line, this project aims to alleviate the chronic traffic congestion in the metropolitan area. Spanning approximately 15 miles, Line 6 will connect the northwest region of Sao Paulo with the downtown area, providing a crucial link for daily commuters. Construction of the Sao Paulo Metro Line 6 commenced in 2015, but faced several delays due to financial and administrative challenges. However, the project gained momentum in recent years, with a renewed commitment to completing this vital infrastructure. The line will include 15 stations, each designed to accommodate a significant number of passengers with modern facilities and accessibility features. The stations are strategically located to serve densely populated neighborhoods, universities, and commercial areas, enhancing the overall connectivity of the city's metro network. One of the significant engineering feats of this project involves the use of tunnel boring machines to excavate the tunnels. These machines, known for their precision and efficiency, are capable of drilling through various soil types found in Sao Paulo. The machines also help minimize surface disruption, a critical factor in a bustling city. The tunnels are reinforced with precast concrete segments, ensuring their structural integrity and longevity. The expected daily ridership of the Sao Paulo Metro Line 6 is projected to exceed 600,000 passengers, significantly reducing the number of vehicles on the road and thereby decreasing traffic congestion and pollution. The integration of this line with other metro lines and bus networks will provide seamless transit options for millions of residents and visitors. The project's budget is estimated at approximately $3 billion, reflecting its scale and complexity. The successful completion of Line 6 is anticipated to not only improve transportation efficiency, but also boost the local economy by creating jobs. It's time to explore the Crescent Dunes Solar Energy Project next, which is a groundbreaking renewable energy initiative located near Tonopah, Nevada. Completed in 2015, this state-of-the-art solar power plant represents a significant leap in solar energy technology, with a price tag of $1 billion. The Crescent Dunes Solar Energy Project was developed by Solar Reserve and is renowned for its innovative use of concentrated solar power technology. Unlike traditional photovoltaic solar plants, Crescent Dunes uses a central tower surrounded by over 10,000 mirrors, known as heliostats. These mirrors track the sun and focus its energy onto the tower, heating molten salt to extremely high temperatures. One of the key advantages of this system is its ability to store thermal energy, allowing the plant to generate electricity even after the sun has set. The Crescent Dunes facility has a capacity of 110 megawatts and can provide power to approximately 75,000 homes. Building the Crescent Dunes solar energy project was a massive undertaking, requiring the coordination of over 1,000 workers during peak construction phases. The project faced numerous challenges, including logistical hurdles related to transporting and assembling the large number of heliostats and constructing the central tower, which stands at 640 feet tall. The project's location in the Nevada desert posed additional difficulties, such as extreme weather conditions and the need to protect the fragile desert ecosystem. Despite these challenges, the project was completed on time and has set a new standard for solar power plants worldwide.
Next up, let's discuss the Glen Canyon Dam that's located on the Colorado River in Arizona. Constructed between 1956 and 1966, the dam was designed to provide water storage, flood control, and hydroelectric power generation for the southwestern United States. The dam created Lake Powell, one of the largest man-made reservoirs in the country, which extends into southern Utah. The construction of the Glen Canyon Dam was a massive undertaking that required extensive planning, innovation, and the overcoming of significant engineering challenges. The dam is a concrete arch-gravity structure standing 710 feet high and 1,560 feet long. It was designed to harness the power of the Colorado River while also providing a stable water supply for agricultural, industrial, and urban use in the region. One of the critical challenges during the construction of the Glen Canyon Dam was the remote location. The site, located in a remote area of the Colorado Plateau, was difficult to access, requiring the construction of roads, bridges, and other infrastructure to support the transport of materials and workers. The dam's construction also involved building the Glen Canyon Bridge, a steel arch bridge that spans 1,271 feet across the canyon, providing essential access to both sides of the construction site. To manage the Colorado River's flow during construction, engineers had to divert the river through tunnels carved into the canyon walls. 2 diversion tunnels, each with a diameter of 41 feet, were excavated through the sandstone bedrock on either side of the river. These tunnels, lined with concrete, allowed the river to bypass the construction site, ensuring that the dam could be built in a dry environment. The foundation of the dam required extensive preparation. Workers excavated the riverbeds down to solid bedrock and ensured a stable foundation for the massive concrete structure. The dam's foundation is key to its stability, allowing it to bear the immense pressure exerted by the reservoir. The concrete used in the dam was placed in blocks, each measuring about 50 feet square and 7.5 feet high. The dam was constructed in a series of these blocks, which were keyed and grounded together to form a solid monolithic structure. The dam's power plant, located at the base of the structure, houses 8 hydroelectric turbines that generate up to 1,320 megawatts of electricity. This power generation capacity has been vital in supporting the electric grid of the southwestern United States. The power plant is also equipped with a series of penstocks, large pipes that carry water from the reservoir to the turbines, allowing for the controlled water release and energy production.
But we have not talked about Sound Transit 3 just yet, which is a monumental transportation infrastructure project aimed at transforming public transit in the Puget Sound region of Washington state. With an estimated budget of $54 billion, ST3 represents one of the largest mass transit expansions in US history. The project extends the existing light rail, commuter rail, and bus rapid transit systems of the region by over 116 miles. Key elements include new light rail lines connecting Seattle to Everett, Tacoma, Ballard, and West Seattle. The project also expands Sounder commuter rail services to South King and Pierce counties and introduces bus rapid transit corridors for faster and more reliable travel. The backbone of ST3 is its light rail network, which will include 37 new stations, bringing the total to over 70. These stations will provide seamless connectivity to major employment centers, residential neighborhoods, and educational institutions. The extension to Tacoma and Everett will significantly reduce travel times, offering commuters a fast, eco-friendly alternative to driving. Light rail trains would run 20 hours per day and every 3 to 6 minutes during peak hours. The plan requires the purchase of 226 new vehicles to operate on the new lines. Sound Transit 3 incorporates advanced technologies to enhance the passenger experience. New stations will feature real-time arrival information, improved accessibility for people with disabilities, and safe, well-lit environments. Parking facilities at key stations will also be expanded to accommodate the growing demand for park and ride services. The ST3 expansion is expected to create thousands of jobs during its construction phase and stimulate economic activity in surrounding areas. By improving access to affordable housing, education, and healthcare, the project also addresses social equity. This ensures that underserved communities benefit from enhanced connectivity. The ambitious scope of ST3 presents several challenges, including budget management, environmental reviews, and community engagement. The pandemic caused delays and increased costs, prompting a re-evaluation of timelines and priorities. Despite these setbacks, major components of the project are expected to be completed by 2041, with interim phases opening earlier. Sound Transit Board has recently approved the route and station locations for the West Seattle Link extension. This action authorizes the project to move forward into the final design phase. Construction is expected to begin in 2027. By 2040, Sound Transit estimates that its services will carry a total of between 561,000 and 695,000 daily riders, with 69% of all transit trips using rail services.
But how about an entire stadium being replaced? The Aloha Stadium Replacement Project, located in Halawa, Hawaii, is a significant undertaking aimed at revitalizing the sports and entertainment capabilities of Hawaii's most populous island, Oahu. This ambitious project replaces the aging Aloha Stadium, originally built in 1975, which had become increasingly costly to maintain and no longer met modern safety or functionality standards. Scheduled for completion in 2028, the new stadium complex is anticipated to cost over $350 million. The project covers an extensive area of approximately 98 acres, with the new stadium expected to seat around 35,000 spectators, down from the old stadium's capacity, but designed to offer improved sightlines and amenities. This size makes it comparable to the StubHub Center in California, though with enhanced technological integrations. Employing around 2,000 workers during peak construction phases, the project faces the unique challenges of building in an island setting, such as logistics complications related to material shipping and the high cost of labor and supplies in Hawaii. The new stadium will employ modern construction techniques, including the use of sustainable materials and energy-efficient designs to minimize its environmental footprint. Features like solar power generation and water reclamation systems are planned to make it one of the greenest stadiums in the nation. A key problem that the new Aloha Stadium aims to solve is the economic inefficiency of its predecessor. The old stadium was underutilized, partially due to its deteriorating condition and lack of modern facilities that limited event hosting capabilities. The new complex, with its state-of-the-art features, seeks to attract more high-profile events and consequently generate significant economic benefits for the region. One innovative aspect of the project is its integrated approach to development. The stadium complex will include mixed-use developments such as hotels, retail spaces, and residential areas, creating a vibrant community hub rather than just a sports venue. This model follows the trend seen in projects like the Atlanta Braves' Truist Park, which integrates a stadium with a larger commercial and residential district.
But just wait until you hear about the Buffalo Bills Stadium, officially named Highmark Stadium. Located in Orchard Park, New York, the project aims to give fans an unparalleled game day experience while boosting regional pride. The original Highmark Stadium, built in 1973, has served as the home for the Buffalo Bills for 5 decades. However, the aging structure no longer meets the demands of modern football or fans. In response, a new $1.5 billion project was approved in 2022, marking the largest investment in Buffalo sports history. The new Buffalo Bills Stadium will cover 1.35 million square feet with a seating capacity of 6,000 talents. It will feature a partial canopy roof to protect fans from Buffalo's unpredictable weather while maintaining an open-air field to preserve the essence of outdoor football. The design includes state-of-the-art amenities like advanced video boards, immersive sound systems, and expansive concourse areas. Enhanced VIP suites, fan zones, and technology-driven experiences aim to elevate spectator engagement. Construction began in early 2023 and is set to complete by the 2026 NFL season. The project uses modular construction techniques, allowing for faster assembly and better quality control. High-strength steel and precast concrete ensure the structure's durability and safety. One of the most impressive aspects of the stadium is the canopy structure. Engineers are using high-strength steel and tension cables to create a lightweight yet durable canopy system. This design minimizes obstructions, ensuring clear sightlines for fans while withstanding harsh weather conditions, including heavy snow and high winds. The foundation of the stadium required extensive excavation and reinforcement to accommodate the weight of the canopy and ensure long-term stability. Advanced drainage systems are being installed to handle Buffalo's frequent rainfall and prevent water damage to the structure. Prefabrication techniques are being used to speed up construction. Components of the canopy and seating sections are manufactured off-site and assembled on-site, reducing costs and construction time. The stadium incorporates sustainable practices, such as energy-efficient systems and rainwater harvesting. Materials are sourced locally to minimize environmental impact, aligning with Buffalo's commitment to green development. The project is expected to create 10,000 jobs during construction and inject millions into the local economy. Once completed, the stadium will host NFL games, concerts, and events, making it a year-round hub for activity and revenue.
Next up, it's time to move over to the country of Uruguay, where the Punta del Tiger power plant stands. This natural gas-fired power plant is one of the largest in Uruguay, with a total generating capacity of 530 megawatts. Construction of the Punta del Tiger power plant began in 2013 and was completed in 2017. The project was implemented in 2 phases, with the first phase involving the construction of a 200-megawatt combined cycle unit, and the second phase adding an additional 330-megawatt unit. The plant utilizes state-of-the-art technology to ensure high efficiency and low emissions, contributing to Uruguay's efforts to reduce its carbon footprint. One of the key features of the Punta del Tiger power plant is its flexibility. The plant can operate on both natural gas and diesel, providing a reliable energy source even in the event of disruptions to natural gas supply. This dual-fuel capability enhances the plant's operational flexibility and energy security. The project faced several challenges, including the need to secure financing and manage environmental and social impacts. The total cost of the Punta del Tiger power plant was approximately $800 million. The project created numerous jobs during the construction phase and continues to provide employment opportunities in the operation and maintenance of the plant. Environmental considerations were integral to the project. The plant incorporates advanced emissions control technologies to minimize its environmental impact, and comprehensive environmental assessments were conducted to ensure compliance with local and international standards. The Punta del Tiger power plant plays a crucial role in Uruguay's energy landscape, providing a reliable and flexible energy source that supports the country's economic growth and development. It's time to delve into the American Dream Meadowlands, a massive entertainment and retail complex located in East Rutherford, New Jersey. With a staggering cost of $5 billion, this ambitious project represents one of the largest mall developments in the United States. Officially opened in phases starting in 2019, American Dream Meadowlands covers approximately 3 million square feet. One of the most striking features of American Dream is its Nickelodeon Universe theme park, the largest indoor theme park in the Western Hemisphere. Adjacent to this is the DreamWorks Water Park, which boasts the largest indoor wave pool. The project faced numerous challenges during its development, including financial difficulties and multiple changes in ownership. Originally conceived in early 2000, the development stalled several times due to economic downturns and funding issues. Despite these setbacks, the project was revitalized and eventually brought to completion, marking a significant milestone in the region's commercial landscape. American Dream's indoor ski slope, known as Big Snow, is another highlight of the complex. It is the first indoor real snow ski and snowboard park in North America, offering year-round winter sports activities. This unique attraction allows visitors to enjoy skiing and snowboarding regardless of the season, making it a significant draw for tourists and locals alike. The construction of American Dream Meadowlands required the coordination of thousands of workers and involved complex engineering and architectural solutions to create its diverse range of attractions. The developers also focused on sustainability, incorporating energy-efficient systems and environmentally friendly practices throughout the complex. The project's strategic location near New York City and major transportation hubs enhances its accessibility, attracting visitors from across the region and beyond. It's time.
Let's travel over to the state of Missouri to investigate Kansas City International Airport's transformed megaproject. The airport has undergone a significant transformation with the construction of a new terminal, replacing the old three-terminal layout that's been in use in the airport's opening since 1972. The new terminal spans approximately 1 million square feet and features a single consolidated structure that replaces the outdated horseshoe-shaped terminal. This design was intended to streamline operations and enhance passenger flow, reducing the complexity of navigating between different terminals. A key aspect of the construction was the airport's location on a former floodplain. Engineers had to ensure that the new terminal was built on solid ground that could withstand potential flooding. The site was prepared by excavating over 1.1 million cubic yards of soil and placing fill material to elevate the ground level, ensuring a stable foundation. In addition, extensive underground utilities were installed to support the terminal's operations. The new terminal structure is primarily composed of steel and reinforced concrete, providing both durability and flexibility. The use of structural steel allowed for large open spaces within the terminal, which is a significant improvement over the cramped and outdated spaces of the previous terminals. The roof of the terminal is supported by a series of large steel trusses, creating a vast column-free interior that enhances the feeling of openness and allows for better natural lighting. One of the challenging engineering aspects of the project was the integration of modern baggage handling and security systems. The terminal includes an advanced baggage handling system capable of processing thousands of bags per hour, which features such an automated sorting and tracking to improve efficiency and reduce the risk of lost luggage. The security checkpoints equipped with the latest screening technology, including automated screening lanes that expedite the process while maintaining high levels of security. The terminal's construction also included the development of new roadways and parking facilities to accommodate the increased passenger capacity. A new multi-level parking garage with over 6,000 spaces was built adjacent to the terminal, providing easy access for passengers and reducing the need for long shuttle rides from distant parking lots. The roads leading to the terminal were reconfigured to improve traffic flow and reduce congestion, with separate lanes for private vehicles, taxis, and buses.
Let's talk about the Brooklyn-Queens Expressway, officially known as Interstate 278. Constructed between 1939 and 1964, this iconic roadway is not just a vital piece of infrastructure, but also a symbol of urban planning challenges. Designed by Robert Moses, the BQE spans 11.7 miles, serving as a critical link for commuters, freight traffic, and tourists navigating the city. The BQE was initially conceived as part of an ambitious plan presented by Moses to modernize New York's roadways. Built to accommodate mid-20th century traffic demands, it became a significant economic driver for the region. However, the design of the expressway, including its cantilevered triple-deck section along the Brooklyn Heights Promenade, was a marvel of its time. It lacked foresight for the growing population and vehicle load of the 21st century. Decades of wear and tear have taken a toll on the BQE, particularly its aging infrastructure, including corroding steel beams and crumbling concrete. The triple cantilever section of the expressway, carrying up to 150,000 vehicles daily, is now considered structurally unsound, leading to urgent calls for reconstruction. The BQE features multiple sections, including elevated, sunken, and cantilevered structures. The cantilevered portion, perched beneath the Brooklyn Heights Promenade, is a unique engineering feat, but presents significant challenges for rehabilitation. It supports 3 layers of traffic and a pedestrian promenade, requiring innovative solutions for repair without disrupting the bustling traffic flow or the community above. Current discussions for the BQE's overhaul include replacing the deteriorating sections with modern materials and designs to accommodate contemporary traffic demands. Estimated costs for reconstruction range from $1.7 billion to $4 billion, depending on the chosen plan. Proposals for the modernization of BQE include building a temporary roadway while repairing the cantilever. They'll probably reroute traffic through adjacent streets, or even convert sections into a boulevard to reduce vehicular congestion. Incorporating sustainable materials, advanced traffic management systems, and noise-reducing technology are integral to these plans. The deteriorating condition of BQE underscores the pressing need for investment in infrastructure.
But what about a country that got a brand new metro system? That's what happened with the Metro de Quito project. The metro line spans approximately 14 miles and includes 15 stations, connecting the southern and northern parts of Quito. Construction of the Metro de Quito began in 2013, and the project faced numerous challenges, including the city's complex geology and the need to preserve historical sites. The metro tunnels were excavated using tunnel boring machines, which allowed for precise and efficient tunneling while minimizing surface disruption. The use of the machines also ensured the protection of Quito's colonial-era buildings and other historical landmarks. The Metro de Quito is designed to accommodate over 400,000 passengers daily, significantly reducing the number of vehicles on the road and improving air quality. The metro system features modern trains equipped with the latest technology, including automated systems for safety and efficiency. The stations are designed to be accessible and user-friendly, with features such as elevators, escalators, and clear signage. One of the significant benefits of the Metro de Quito is the reduction in travel time. Commuters can travel from one end of the city to the other in approximately 34 minutes, compared to over an hour by car during peak traffic. This improvement in mobility is expected to boost economic activities and enhance the quality of life for Quito's residents. The total cost of the Metro de Quito project is estimated at $2 billion, funded by a combination of national and international sources. The project has generated significant economic benefits, including job creation during the construction phase and increased commercial activities around the metro stations. Environmental sustainability is a key aspect of the Metro de Quito project. The metro system is powered by electricity, reducing greenhouse gas emissions and contributing to Quito's efforts to combat climate change. The project also includes measures to manage noise and vibration, ensuring minimal disruption to the surrounding communities. But have you ever heard of the Intel semiconductor plant? With an estimated cost of $20 billion, this state-of-the-art facility represents one of the largest and most ambitious semiconductor manufacturing endeavors in the United States. Located in Chandler, Arizona, the project began its construction in 2011 and has seen continuous upgrades to remain at the cutting edge of semiconductor technology. The plant spans several 100,000 square feet and is designed to produce Intel's most advanced chips, including those built on the company's latest process technologies. A standout feature of the Intel semiconductor plant is its use of advanced manufacturing techniques, which enable the production of chips with transistors measuring just a few nanometers in size. This precision is essential for creating the powerful and efficient processors that drive today's electronics, from computers and smartphones to data centers and AI applications. The facility is also a model of sustainability and environmental stewardship. Intel has implemented numerous green initiatives at the plant, including energy-efficient designs, extensive water recycling systems, and waste reduction programs. Intel's plant plays a critical role in the company's global supply chain, helping to meet the ever-growing demand for semiconductors. This demand has been driven by the proliferation of digital devices, the expansion of cloud computing, and the increasing integration of artificial intelligence into various sectors. The plant's production capacity is essential for ensuring that Intel can supply the chips needed to power the technological innovations of today and tomorrow. The strategic importance of the Intel semiconductor plant extends beyond its manufacturing capabilities. It represents a significant investment in the U.S. economy, creating thousands of high-tech jobs and fostering innovation in the semiconductor industry. The plant also contributes to the nation's technological independence, reducing reliance on overseas chip manufacturing and enhancing the resilience of the supply chain. Next up.
But we have to talk about the largest LNG projects ever in the United States. The Rio Grande LNG terminal, located at the port of Brownsville in Texas, aims to become a major LNG export facility that will handle up to 27 million tons per annum of liquefied natural gas once fully operational. The terminal's design includes significant infrastructure, such as multiple LNG storage tanks, each capable of holding 180,000 cubic meters of LNG, and 2 marine berths to accommodate LNG carriers of up to 185,000 cubic meters capacity. One of the engineering challenges of the project is the site's location along the Brownsville Ship Channel, a highly active industrial waterway with specific environmental and logistical requirements. The construction site required extensive preparation, including soil stabilization and the installation of a comprehensive levee system around the perimeter to protect against flooding and manage stormwater runoff. The soil stabilization process involved deep mixing techniques to ensure a solid foundation for the massive structures, particularly in the areas where the liquefaction trains and storage tanks are being built. The LNG production process at the terminal involves cooling natural gas to negative 162 degrees Celsius to liquefy it, reducing its volume by about 600 times for easier storage and transportation. This process demands substantial energy, requiring the installation of robust power generation facilities and cooling systems. The engineering work includes laying down extensive pipelines to bring feed gas to the site and distributing it to the liquefaction trains. The liquefaction trains themselves are highly complex systems, each containing multiple stages of compression and heat exchange to achieve the necessary cooling of the gas. These trains are built using modular construction techniques, allowing large components to be prefabricated off-site and then transported to Brownsville for assembly. This approach minimizes on-site construction time and reduces potential delays. The terminal also includes significant safety and monitoring systems. Given the flammable nature of LNG, the design integrates advanced fire detection and suppression systems, extensive monitoring of gas leaks, and robust emergency response plans. Additionally, the terminal will feature a network of control rooms and automation systems to manage the operation of the liquefaction trains, storage tanks, and loading berths efficiently and safely. The engineering behind the Rio Grande LNG terminal also includes provisions for future expansion. The site's being prepared to potentially add additional liquefaction trains and storage capacity as market demands grow. This forward-thinking approach to the terminal's design ensures that it can adapt to future energy needs.
Let's travel to Tolosa, a brand new $400 billion future city planned in the States. It's a futuristic city, taking shape in the imagination of tech billionaire Mark Law. Tolosa promises to combine the cleanliness of Tokyo, the diversity of New York, and the social services of Stockholm into a groundbreaking urban design. The name of the city comes from Greek, which means something like highest goal. This refers to both sustainability goals and the diversity of the population. Law got this idea from the economist Henry George, who dreamed of a tax-free, communal form of society as early as the 19th century. However, this has so far only been implemented on a very small scale. This gigantic city, around the size of Chicago, will rise from scratch in the middle of desert, covering 150,000 acres. With a vision for sustainability and equity, Tolosa will feature eco-friendly architecture, renewable energy systems, and a drought-resistant water supply. Its 15-minute city design ensures residents can reach schools, workplaces, and amenities within a quarter-hour commute. Planners are scouting locations in Nevada, Utah, Idaho, Arizona, Texas, and the Appalachian region. Digital renderings by Bjarke Ingels Group depict lush greenery on buildings, abundant open spaces, and sunlit streets filled with autonomous vehicles, pedestrians, and bicycles. Fossil fuel-powered vehicles will be banned, creating a clean, quiet, and sustainable transport ecosystem. Smart infrastructure will track energy use, traffic, and public services in real time. Equitism Tower will be built as the Tower of Sustainability. This skyscraper will feature elevated water storage, aeroponic farms, and a photovoltaic roof that generates energy. The tower is designed to share resources efficiently, embodying Tolosa's vision for self-sustaining communities. The first phase of Tolosa will cover 1,500 acres and house 50,000 residents. Estimated costs for this phase alone are $25 billion, while the entire project is expected to exceed $400 billion. Construction will use advanced technologies, including 3D printing, modular construction methods, and renewable materials to minimize environmental impact. Heavy equipment like electric excavators and robotic construction systems will speed up development while maintaining precision. The project is set to break ground by 2030, with a goal of reaching a population of 5 million within 40 years. The governance in Tolosa will emphasize participation and equity, inspired by the philosophy of Henry George. Residents will have a say in budgeting and decision-making processes. Law envisions a city where people, not profits, are at the center, describing it as the most open, fair, and inclusive city in the world. Tolosa's unique economic model, equitism, gives residents shared ownership of city land. A foundation will manage land sales, using profits to fund public services. Once the city thrives, its residents will prosper. However, this model requires strong public and philanthropic support to succeed. Tolosa faces significant hurdles, particularly in water availability. Building in the desert means addressing drought risks and water rights. Critics argue resources might be better spent retrofitting existing cities. For law, the challenge is proving that starting fresh allows for groundbreaking solutions.
It's time to move over to Boston now for the Green Line Extension Megaproject. This extension aims to enhance public transit services by connecting the densely populated but underserved areas of Somerville and Medford to the existing subway network, thereby increasing accessibility to central Boston. Launched with major construction efforts ramping up around 2018, the GLX project completed in 2023. The project's budget, initially estimated at $2 billion, saw an increase to nearly $2.3 billion due to unforeseen construction and environmental challenges. Spanning approximately 4.7 miles, the GLX adds 7 new stations along 2 branches, one terminating at Union Square in Somerville and the other at Tufts University in Medford. These new tracks and stations are expected to serve about 45,000 riders daily, significantly easing traffic congestion and reducing commute times in these high-density corridors. The workforce required for this mammoth project varied throughout its phases, involving up to 1,000 construction workers and engineers at peak times. One of the most critical problems the GLX project addresses is the reduction of vehicle emissions by providing a reliable and efficient public transit alternative, thereby contributing to the state's environmental goals. In terms of construction, the GLX employed advanced methods, including the use of track-laying machines that allowed for faster, more efficient installation of rail lines. This project also involves substantial upgrades to existing infrastructure, such as the improvement of bridges and roads along the extension path, ensuring that the new service would be integrated smoothly with minimal disruption. Challenges encountered during the GLX project included managing complex logistics in densely populated areas, mitigating noise and disruption to local communities, and addressing cost overruns and delays, which were exacerbated by the pandemic.
But have you ever heard about the remarkable Spiral Tower? Rising 1041 feet above Hudson Yards in Manhattan, the Spiral is a $3.7 billion skyscraper that redefines sustainable and innovative architecture. The Spiral was conceived as a mixed-use development offering office spaces, retail, and public amenities. Its name comes from the cascading terraces that spiral around the building, creating a continuous ribbon of green spaces from top to bottom. This unique feature connects all floors with landscape terraces, symbolizing an architectural evolution toward greener urban environments. The tower provides 2.85 million square feet of office space and luxurious amenities. A striking feature is its 66th floor, open-air terrace and clubhouse, offering panoramic views of the city. The interiors seamlessly blend modern aesthetics with functionality, creating an atmosphere of sophistication. Its facade features high-performance glazing to maximize natural light while minimizing heat gain, contributing to energy efficiency. The advanced irrigation system conserves 4.5 million gallons of water annually compared to traditional systems. Its construction involved modular building techniques, accelerating the assembly of its complex design. Steel and concrete were the primary materials, ensuring structural integrity while accommodating its unique spiraling terraces. Prefabricated components were brought to the site and assembled with millimeter precision, reducing construction time and waste. To ensure stability, engineers implemented an advanced core and outrigger system, which provides resistance against wind forces and seismic activity. The building also features rainwater collection systems integrated into the terraces, enabling irrigation for the lush greenery. The spiral incorporates cutting-edge sustainable technologies. Its green terraces improve air quality and reduce urban heat, while smart systems monitor and optimize energy use in real time. The building also includes advanced HVAC systems and water-efficient plumbing, reducing its environmental footprint.
It's time to move over to Colombia next for the Orient Tunnel project. Designed to improve connectivity between Medellin and the José María Cordova International Airport in Riongro, this road tunnel is the longest in Colombia, spanning approximately 5.7 miles. Construction of the Túnel de Orient began in 2012 and was completed in 2019. The project involved extensive geological surveys and the use of advanced tunneling techniques to navigate the complex terrain of the Andes Mountains. The tunnel features dual bores, each accommodating 2 lanes of traffic, ensuring a smooth flow of vehicles and enhancing safety. One of the key benefits of the Túnel de Orient is the reduction in travel time. Prior to the tunnel's construction, the journey between Medellin and the airport took approximately 45 minutes to an hour, depending on traffic conditions. The tunnel reduces this travel time to just 18 minutes, providing a more direct and efficient route. The total cost of the Túnel de Orient project was approximately $300 million, funded by a combination of public and private investment. The project has generated significant economic benefits, including job creation during the construction phase and increased commercial activities once the tunnel became operational. Environmental and social considerations were integral to the project. Comprehensive environmental impact assessments were conducted to minimize the impact on local ecosystems and communities. The project also included measures to manage water resources, protect wildlife, and engage with local stakeholders to ensure that the benefits of the tunnel are shared with the surrounding areas. It's time to explore the Kennedy Space Center, a monumental project that stands as a pinnacle of aerospace engineering. Located on Merritt Island, Florida, this iconic facility was established in 1962 and became operational during the height of the space race. The total cost of constructing and developing the Kennedy Space Center is estimated at approximately $2 billion. The Space Center spans 144,000 acres and serves as NASA's primary launch center for human spaceflight. Its construction required the efforts of thousands of engineers, technicians, and laborers working around the clock to bring this ambitious project to fruition. The center's most famous feature is Launch Complex 39, which includes 2 launch pads and the massive vehicle assembly building. The VAB is one of the largest buildings in the world by volume and was designed to assemble the Saturn V rocket, the behemoth that carried astronauts to the moon during the Apollo program. The Kennedy Space Center was not just built for the Apollo missions. It has been instrumental in numerous space endeavors, including the Space Shuttle program and, more recently, SpaceX's commercial crew missions. The facility's infrastructure includes a network of crawler transporters that move rockets from the VAB to the launch pads, a distance of about 3 miles. These crawlers are engineering marvels in their own right, capable of carrying the immense weight of fully assembled rockets. One of the significant challenges faced during the construction of the Kennedy Space Center was managing the environmental impact on the surrounding Merritt Island National Wildlife Refuge. This required careful planning and innovative solutions to ensure that the center's operations did not adversely affect the local ecosystem. To understand the scale of the Kennedy Space Center, consider that its launch pads and support facilities occupy an area equivalent to about 219 football fields. The center has continuously evolved, incorporating cutting-edge technology and infrastructure to support the ever-advancing field of space exploration.
We move over to Seattle next, where the Alaskan Way Viaduct Replacement Tunnel project stands. This project replaced the aging and seismically vulnerable Alaskan Way Viaduct with a 1.7-mile-long double-deck highway tunnel running beneath downtown Seattle. The tunnel is part of a State Route 99 and was constructed to improve safety, reduce congestion, and enhance the city's waterfront area. The tunnel's construction utilized a tunnel boring machine named Bertha, which was, at the time, the largest of its kind in the world, with a diameter of 57.5 feet. Bertha's journey began in July 2013, but the project faced significant challenges soon after. In December 2013, the TBM came to an unexpected halt after encountering a steel pipe, which damaged the machine's cutting blades. This led to a prolonged repair period that lasted nearly 2 years. The TBM was eventually repaired by excavating a recovery shaft from which engineers accessed and lifted the front of the machine to replace the damaged parts. The tunnel boring process resumed in December 2015, and Bertha continued to carve its way beneath Seattle at an average depth of about 200 feet below the surface. The tunnel was constructed using a segmented ring system, where each ring is made up of 10 precast concrete segments. As Bertha moved forward, these segments were installed to form the tunnel's lining, providing structural support and preventing groundwater ingress. To ensure the tunnel's long-term durability and safety, engineers used a comprehensive monitoring system to track Bertha's progress and the surrounding ground conditions in real time. This system included sensors embedded in this tunnel's lining and the ground above, allowing for immediate detection of any movement or settlement that could indicate potential issues. One of the complex aspects of the construction was managing the groundwater and ensuring the tunnel remained watertight. The tunnel passes through the Duwamish River's alluvial deposits, which are prone to high groundwater pressure. To address this, Bertha was equipped with a pressurized front shield that balanced the pressure at the tunnel face, preventing water from flooding the excavation chamber. The final breakthrough occurred in April 2017, marking the completion of Bertha's journey. However, the project was far from over, as extensive work was required to outfit the tunnel with necessary infrastructure, including roadways, ventilation systems, fire suppression systems, and emergency egress routes. The tunnel officially opened to traffic in February 2019, replacing the viaduct and transforming Seattle's waterfront.
Next up, we have to talk about the $119 billion New York City Seawall project, an ambitious response to rising sea levels and increasing storm surges. Known as the Big U, this protective infrastructure aims to shield the city from the devastating effects of climate change. The devastating impact of Hurricane Sandy in 2012 underscored the vulnerability of the city to extreme weather events, with over $70 billion in damages. In response, the U.S. Army Corps of Engineers developed the New York Harbor Storm Surge Barrier Plan. The seawall will stretch approximately 6 miles along the coastline, acting as a barrier to shield New York Harbor and Lower Manhattan from extreme weather events. This ambitious project will storm gates, levees, and natural wetlands restoration to absorb water and reduce storm impact. This 20-foot-tall seawall is part of a $10 billion plan to climate-proof New York City. It will include a public walkway that can host events like concerts and marathons. Building a seawall of this magnitude requires advanced engineering to ensure resilience against powerful storms and rising tides. Engineers are using a combination of reinforced concrete and steel structures to construct the barrier. Deep foundation piles are driven into the seabed to anchor the wall securely. The project also integrates movable storm gates, which can close during severe weather and reopen for normal maritime traffic. hydrodynamic modeling and simulations were conducted to optimize the design and placement of walls. Advanced modeling techniques, including AI-based simulations, have been employed to predict storm behavior and optimize barrier placement. The wall incorporates tidal gates to maintain water flow and preserve the ecological balance of the harbor. Some sections feature living shorelines, blending natural habitats with engineered defenses to promote biodiversity and reduce wave energy. The project involves dredging, reinforced piling, and innovative materials resistant to erosion and saltwater corrosion. Despite the staggering cost of $119 billion, the seawall is projected to save over $200 billion in potential damages. Once completed, the seawall will protect New York City from catastrophic flooding and redefine urban waterfront living.
But have you ever heard about the construction of the Puente Pumerjo? This cable-stayed bridge spans the Magdalena River in Colombia, providing a critical transportation link between the eastern and western parts of the city and improving connectivity for the entire region. Construction of the Puente Pumerjo began in 2015 and was completed in 2019. The bridge is approximately 1.5 miles long and features a central span of 722 feet, supported by two main pylons rising 492 feet above the river. The bridge's design includes 4 lanes of vehicular traffic, as well as pedestrian and bicycle pathways, enhancing its accessibility and functionality. One of the significant engineering challenges of the Puente Pumerjo project was the need to accommodate the large volume of river traffic passing beneath the bridge. The bridge's clearance of 148 feet allows for the passage of large vessels, including cargo ships and riverboats, ensuring the continued flow of commerce along the Magdalena River. The construction process also involved advanced techniques for pile driving and cable installation, ensuring the structural integrity and durability of the bridge. The bridge has generated significant economic benefits, including reduced travel time, increased trade, and enhanced regional connectivity. The project also created numerous jobs during the construction phase and continues to support local economic activities. Next up, let's delve into the monumental Houston Metrorail expansion project, a $7.5 billion undertaking that aims to revolutionize public transit in Houston, Texas. Spanning an impressive 20 miles of additional track, the Metrorail expansion is designed to connect more neighborhoods and increase accessibility across the city. The project involves intricate construction phases, which began in earnest in 2021 and are scheduled to reach completion by 2028. Over the course of these 7 years, the landscape of Houston will see transformative changes. Houston's flat and expansive geography presents unique challenges. Engineers are continuously combating the city's soft soil, which is prone to shifting and sinking. This has led to the innovative use of deep concrete pilings and reinforced steel to ensure the stability of tracks and stations. The project also incorporates elevated sections and raised platforms, designed to withstand Houston's frequent floods, thereby safeguarding the transit system's operational integrity during severe weather conditions. Each new station along the expansion route is being built with more than functionality in mind. They are envisioned as community hubs, equipped with modern amenities, real-time travel information, and artwork reflective of local culture. Despite the benefits, the path hasn't been entirely smooth. Issues ranging from logistical challenges, such as coordinating with existing traffic and utility lines, to public opposition concerning construction disruptions, have tested the project's resilience. The project management team has had to innovate on the fly, employing cutting-edge construction techniques and real-time problem-solving to keep the project on track. Specialized construction methods like the use of silent piling technology to minimize noise in residential areas and the application of advanced GPS and GIS for precision in layout and execution highlight the technical sophistication of this expansion. Let's travel.
But we have to move over to San Francisco next to talk about the extremely tall Salesforce Tower. Completed in 2018, this is a striking example of modern skyscraper engineering. Standing at 1,070 feet tall, it is the tallest building in San Francisco and one of the tallest in the western United States. The tower's construction required cutting-edge engineering to address both the aesthetic and functional demands of a high-rise building in a seismically active region. The foundation of the tower had to be exceptionally robust to ensure the building's stability during an earthquake. It's also supported by a massive concrete mat foundation that is 14 feet thick and sits atop over 42 steel-reinforced concrete piles driven deep into the bedrock. These piles reach depths of 300 feet below ground, anchoring the structure securely to withstand seismic forces. The building's core structure is composed of a high-strength steel frame designed to provide both flexibility and strength. It consists of movement-resisting frames, or MRFs, that allow the building to flex slightly during seismic events, dissipating the energy and reducing the risk of structural failure. The building also features a reinforced concrete core that houses the elevators and emergency stairwells, providing additional rigidity to the structure. The exterior of Salesforce Tower is clad in a curtain wall system made up of aluminum and glass panels. The system was designed to be both aesthetically pleasing and highly functional. The curtain wall includes high-performance glazing that reduces solar heat gain, thus lowering the building's cooling requirements. The facade's design also helps to minimize wind loads, which is critical for a building of this height. Construction of the tower involved the use of advanced construction techniques to manage the challenges of building in a dense urban environment. The tower was built using a top-down construction method, which allowed for the simultaneous construction of the superstructure and the below-grade levels, including the basement and foundation. This method not only sped up the construction process, but also minimized disruptions in the surrounding area. The crown of Salesforce Tower is another engineering feat. It includes a 150-foot sculptural extension that houses a unique LED art installation. This extension required a precise engineering to ensure it could withstand the wind and seismic forces while maintaining its aesthetic integrity.
We have to talk about the redevelopment of one of the busiest airports in the country, John F. Kennedy International Airport. This project is worth $19 billion and is all set to redefine air travel for one of the busiest hubs in the United States. With over 62 million passengers passing through annually, JFK is integral to global connectivity. The airport generates more than $51 billion in sales and $17.1 billion in wages. This massive project ensures that the airport not only meets current demands, but is also prepared for future growth. The JFK International Airport Master Plan to redevelop the airport into a world-class 21st century airport is being led by Grimshaw and Mott MacDonald. The expansion will result in new terminal complexes on both the south and north sides of the airport. To the south, Terminals 1 and 2 will be replaced with a new terminal served by 23 international gates. On the north side, another upgraded terminal will connect to the existing Terminal 5 and offer 12 international gates, each able to serve larger wide-body aircraft. Other expansion projects include a 16-gate expansion for Terminal 4 and a 3-gate expansion at Terminal 8. The project also focuses on enhancing the passenger experience through modern design, spacious concourses, advanced technology, and sustainable features. Improvements include better check-in areas, automated security systems, and a wider range of retail and dining options. Upgraded baggage handling systems will streamline operations, reducing delays and improving efficiency. To complement the terminal upgrades, the project includes a redesign of roadways and parking areas to ease congestion and improve traffic flow. Expanded air train capacity will provide a seamless connection to public transportation. Similarly, upgrades to taxiways and aprons ensure better aircraft movement on the ground. With new roads, bridges, and enhanced traffic technologies, travelers will have an easier time navigating between terminals. They are also reducing the number of roadway loops from 5 to 2 main loops, making it less confusing for drivers. This will eventually create space for more cars to circle through, but less congestion to stack up. This includes a multi-level parking facility with nearly 2,000 spaces and an eco-friendly timber exterior. A 122-meter pedestrian bridge equipped with rainwater harvesting technology will link it to the new Terminal 1. The expansion has faced challenges, including coordination with airlines, minimizing disruption during construction, and managing costs. The city is also building its own concrete plant to produce the roughly 550,000 square meters expected to be used at JFK. That's enough to fill about 218 Olympic swimming pools. Despite several hurdles, the project remains on track, with completion expected by 2030.
Next up, it's time to travel to New York for the Bayonne Bridge raising project. This development is an extraordinary engineering feat located over the Kill-Van-Kull Strait, connecting Staten Island, New York to Bayonne, New Jersey. This project was initiated to address the critical need for modern cargo ships to access the ports of Newark and Elizabeth, New Jersey, which are among the busiest on the eastern seaboard. The original bridge, completed in 1931, had a navigational clearance that was too low for the new generation of ultra-large container vessels introduced with the expansion of the Panama Canal. Completed in 2019, the project successfully raised the bridge's roadway from 151 feet to 215 feet above the water level, while also maintaining the iconic arch design. This adjustment made it possible for ships nearly twice the size of those previously accommodated to pass underneath, significantly increasing the operational capacity and efficiency of the port facilities. The project cost was approximately $1.7 billion, reflecting both its scale and complexity. One of the significant challenges was executing the work without disrupting the heavy vehicular traffic on the bridge, which necessitated innovative construction methods and careful scheduling. In terms of its engineering methodology, the project was notable for its use of the raise the roadway technique. This method involved building a new roadway above the existing one while traffic continued below, and then removing the lower roadway upon completion. Comparing the scale of the Bayonne Bridge project to other engineering projects, its new 215-foot clearance is high enough to accommodate an NFL football field standing on end. The Bayonne Bridge raising faced numerous challenges during its execution, including technical difficulties inherent in working with existing structures, the need to maintain stringent safety standards, and the unpredictable weather conditions over the strait. The project also had to navigate complex regulatory and environmental approvals, coordinating with multiple governmental bodies and community stakeholders to mitigate impacts on the surrounding areas.
It's time for a much taller project called 270 Park Avenue, which is soon to be the global headquarters of JP Morgan Chase. Towering 1,388 feet with 60 stories, this state-of-the-art structure redefines the workplace with cutting-edge technology, sustainability, and architectural innovation. The previous structure at 270 Park Avenue, built in the late 1950s, was designed for 3,500 employees. However, as JP Morgan Chase grew, so did its needs. The new tower, conceptualized as a timeless addition to the skyline in New York, will accommodate up to 14,000 employees. Its design celebrates iconic architecture in legacy while embracing the future of workplace environments with flexibility and collaboration at its core. The building has a state-of-the-art gym, gourmet dining, and outdoor terraces with skyline views. The project began with the demolition of the original building in 2019, marking one of the largest voluntary demolitions of a structure in history. Remarkably, 97% of the materials from the old building were recycled or upcycled, far exceeding industry standards for green building projects. The new tower is being built using a hybrid structural system of steel and reinforced concrete. This all-electric tower will be the largest in New York City with net zero operational emissions. Powered entirely by renewable energy from a New York State hydroelectric plant, the building incorporates advanced systems to ensure energy efficiency. Features include triple-pane glazing on the facade and automatic solar shades integrated with HVAC systems. These also include intelligent building technology that uses sensors and AI to optimize energy consumption. Water efficiency is another highlight, with advanced storage and reuse systems reducing water consumption by over 40%. The terraces in the building and a large public plaza offer natural green spaces, enhancing urban biodiversity and promoting well-being for workers and visitors alike. The unique structural system of the building employs fan columns and triangular bracing, enabling it to lift 80 feet off the ground. This creates an expansive open area at street level, offering 2.5 times more outdoor space along Park and Madison Avenues. Wider sidewalks and public plazas make the area more pedestrian-friendly while maintaining a seamless architectural flow.
We have to travel over to Peru now for the Chinchero International Airport construction project. Located near Cusco, it's a major infrastructure project designed to enhance the region's connectivity and support the growing tourism industry. Cusco is the gateway to Machu Picchu, one of the world's most popular tourist destinations, and the new airport aims to accommodate the increasing number of visitors while alleviating congestion at the existing Alejandro Velasco Esteve International Airport. Construction of the Chinchero International Airport began in 2018, with the project expected to be completed by 2025. The airport will feature a modern terminal building, a 13,000-foot runway, and state-of-the-art navigation and communication systems. The terminal will be designed to handle up to 5 million passengers annually, providing a significant boost to the region's tourism infrastructure. One of the key engineering challenges of the Chinchero International Airport project is its location at an altitude of approximately 12,500 feet above sea level. The high-altitude environment presents unique challenges for aircraft performance and passenger comfort, requiring specialized design and operational considerations. The project also involves extensive earthworks and site preparation to ensure the stability and safety of the airport infrastructure. The total cost of the Chinchero International Airport project is estimated at $500 million, funded by the Peruvian government and international investors. The project is expected to generate significant economic benefits, including job creation during the construction phase and increased tourism revenue once the airport is operational. Next, let's explore the Las Vegas Convention Center expansion. With a total investment of $4.3 billion, this expansion project significantly enhances the capabilities and allure of one of the world's largest convention centers. Officially completed in 2021, the Las Vegas Convention Center expansion spans 1.4 million square feet, adding substantial new space to the existing facility. The project includes the new West Hall, which alone provides an additional 600,000 square feet of exhibit space, complemented by a stunning 14,000 square foot outdoor terrace offering breathtaking views of the Las Vegas Strip. One of the most innovative aspects of the expansion is the integration of the LVCC Loop, an underground transportation system developed by Elon Musk's The Boring Company. This system features autonomous electric vehicles that transport attendees between the convention center's different halls at high speeds, significantly reducing transit times across the vast complex. The expansion was driven by the growing demand for large-scale event spaces in Las Vegas, which hosts numerous high-profile conventions, trade shows, and corporate events annually. Construction of the expansion required the coordination of thousands of workers and the use of cutting-edge building techniques to ensure that the project met its ambitious goals on time and within budget. Despite the challenges posed by the pandemic, the project team implemented rigorous health and safety protocols to keep the work on track. Sustainability was also a key focus of the expansion, with the new West Hall designed to achieve LEED certification for its environmentally friendly features. These include energy-efficient lighting, water-saving fixtures, and the use of sustainable materials throughout the construction process. In addition to the increased exhibit space, the expansion features advanced technological infrastructure, including high-speed internet and state-of-the-art audiovisual capabilities to meet the needs of modern events and exhibitions.
We move over to New York for the Hudson Yards project, a $25 billion mega project on the west side of Manhattan. Is the largest private real estate development in America's history. Spanning 28 acres, this transformative project has redefined urban living and set a new standard for mixed-use developments. The project features The Edge, which is the highest outdoor sky deck in the Western Hemisphere. This will include more than 18 million square feet of commercial and residential space, along with more than 100 shops. There'll be a collection of restaurants, approximately 4,000 residences, and affordable housing. Then there is The Shed, a cultural venue that hosts performances, art exhibits, and events. This 14 acres of public open space will also include a 750-seat public school, the inaugural Equinox Hotel with 212 rooms, and a first-of-its-kind microgrid and cogen plant. Hudson Yards includes luxury apartments with stunning views and cutting-edge amenities. There'll also be office spaces for major corporations like Facebook, L'Oreal, and Warner Media. This blend of living and working spaces creates a dynamic, self-sustaining community. The shops and restaurants at Hudson Yards offer a premier shopping and dining experience with high-end retailers and world-class chefs. It has become a destination for locals and tourists alike. Hudson Yards incorporates sustainable design elements, including energy-efficient buildings, green roofs, and a district-wide microgrid for power and heating. Residences feature high ceilings and custom interiors, along with a range of state-of-the-art features. From filtered fresh air ducts to Lutron home automation, the development aims to reduce its environmental footprint while creating a modern urban experience. This mega project has created tens of thousands of jobs and generated billions in economic activity. It has also revitalized the west side of Manhattan, turning a once industrial area into a thriving neighborhood. Hudson Yards has faced criticism for its high costs, exclusivity, and limited affordability. Some argue that it caters to the wealthy while neglecting the needs of lower-income residents.
Moving over to Chicago, we have to talk about the Lincoln Yards megaproject. This expansive plan, spearheaded by Sterling Bay, is a $6 billion redevelopment plan that is reshaping over 55 acres of former industrial land into a vibrant, mixed-use complex. Upon its phased completion, with projections spanning the next decade, Lincoln Yards aims to serve as a new epicenter for residential living, commercial activity, and cultural flourish in Chicago. A pivotal element of Lincoln Yards is its promise to create upwards of 24,000 full-time jobs during its construction phases, involving a vast array of trades and specialties. At its core, Lincoln Yards is designed to address the pressing need for urban revitalization and connectivity between Chicago's northwestern neighborhoods, effectively bridging a gap that has long segmented the city. The development encompasses over 14 million square feet of buildings, including high-rise residential towers, office buildings, and an array of retail spaces. One of the major challenges Lincoln Yards faces is integrating this vast new development seamlessly with existing infrastructure. The plan includes substantial improvements to local transit systems and roadways, including a new Metro train station, multiple new bridges over the Chicago River, and enhanced pedestrian and bike paths to ensure accessibility and reduce traffic congestion. An ambitious aspect of the Lincoln Yards project is the proposed Live Nation Entertainment District, which will include multiple venues for concerts and cultural events, capable of hosting thousands of visitors. This entertainment component is envisioned to be comparable in scale to London's O2 Arena district, albeit integrated within a larger mixed-use development. But what about a brand new tunnel that's currently being built? The Túnel del Toyo, currently under construction in Colombia, is set to become the longest road tunnel in Latin America. Spanning approximately 6.2 miles, this ambitious project aims to significantly reduce travel time between Medellin, Colombia's second-largest city, and the key port of Urabá. This reduction in travel time is expected to boost trade and economic activities in the region. Construction of the Túnel del Toyo began in 2015, and the project is expected to be completed by late 2024. The tunnel will cut through the rugged Andean mountains, presenting numerous engineering challenges. The project involves extensive geological surveys and the use of advanced tunneling techniques to navigate the complex terrain safely. The Túnel del Toyo is designed as a dual-bore tunnel, with each bore accommodating 2 lanes of traffic. This design ensures a smooth flow of vehicles and enhances safety. The project also includes the construction of access roads and ventilation systems to maintain air quality within the tunnel. One of the critical benefits of the Túnel del Toyo is the expected reduction in travel time. Currently, the journey between Medellin and Urabá takes about 6 hours by road, traversing winding mountain roads that are often prone to landslides and other hazards. The tunnel will cut this travel time to approximately 3 hours, providing a more direct and safer route. The Túnel del Toyo project is estimated to cost around $1 billion, with funding sourced from both national and regional governments. Environmental considerations are also a key aspect of the project. The construction process includes measures to minimize the impact on local ecosystems, such as the relocation of wildlife and reforestation efforts. The tunnel's design also incorporates advanced drainage systems to manage water flow and prevent flooding. Let's delve into the Northgate Link extension, a transformative addition to Seattle's public transportation network. Completed at a cost of $1.9 billion, this project is a cornerstone of the region's efforts to enhance urban mobility and reduce traffic congestion. Breaking ground in 2012 and opening to the public in October 2021, the Northgate Link extension stretches the city's light rail system by 4.3 miles, connecting the University of Washington to Northgate. This crucial extension includes 3 new stations, strategically located to serve key residential and commercial hubs in northern Seattle. A defining feature of the Northgate Link extension is the engineering marvel of its twin tunnels, constructed using state-of-the-art tunnel boring machines. These machines, dubbed Brenda and Pamela, excavated deep beneath the city, navigating complex soil conditions and existing underground infrastructure with remarkable precision. The construction process engaged thousands of workers and required intricate planning and coordination. Each new station is designed with a focus on accessibility, safety, and community integration, featuring modern amenities and public art installations that enhance the commuter experience. The Northgate Link extension significantly reduces travel times, with the journey from Northgate to downtown Seattle now taking just 14 minutes. This improvement is expected to ease road traffic and provide a reliable alternative to driving, fostering greater use of public transportation. The project's impact on Seattle's urban landscape is profound, revitalizing neighborhoods and stimulating economic growth around the new stations.
Next up, it's time to travel over to Boston to talk about the Ted Williams Tunnel, which is a key component of the larger Central Artery project. The tunnel, which connects South Boston to Logan International Airport, was constructed to alleviate congestion and provide a direct route under Boston Harbor. Construction of the tunnel began in 1991 and was completed in 1995, with the tunnel officially opening to traffic in December 1995. The project is notable for being the first major tunnel in the United States constructed using an immersed tube technique. This method involved constructing the tunnel sections on land and then floating them to the site, sinking them into pre-dredged trenches on the harbor floor and connecting them underwater. The tunnel comprises 12 precast concrete sections, each approximately 325 feet long and weighing about 23,000 tons. These sections were built at a casting basin in East Boston, floated into position in Boston Harbor, and then carefully submerged into place. The construction of the tunnel required extensive dredging of Boston Harbor to create the trench where the tunnel sections would be placed. This dredging was a significant logistical challenge, given the need to manage harbor traffic and ensure the environmental safety of the surrounding waters. The trench was approximately 50 feet deep, with a width of around 90 feet. After the tunnel sections were placed in the trench, they were connected and sealed together to create a watertight structure. One of the most critical aspects of the tunnel's construction was ensuring the sections were perfectly aligned and securely connected underwater. To achieve this, engineers used a combination of hydraulic jacks, precise surveying equipment, and underwater divers. The alignment and sealing process required meticulous attention to detail to prevent leaks and ensure the long-term integrity of the tunnel. The tunnel structure is composed of high-strength concrete, reinforced with steel rebar to withstand the pressures of being submerged underwater and the loads from traffic above. The tunnel walls are 3 feet thick, providing significant durability and resistance to potential impacts or structural shifts. The interior of the tunnel features a ventilation system designed to manage vehicle emissions and ensure air quality within the tunnel, with large fans installed at intervals to circulate fresh air. Another engineering challenge was the need to connect the submerged tunnel sections to the land-based approach structures on both sides of the harbor. This transition between the immersed tube and the cut-and-cover tunnels required careful design to accommodate the different construction methods and ensure a seamless connection.
City. Let's move over to Nevada for the Tesla Gigafactory. With an estimated cost of $16 billion, this massive facility is revolutionizing battery production and energy storage. Gigafactory Tesla is one of the highest volume plants in the world for electric motors, energy storage products, vehicle powertrains, and batteries. Located near Reno, Nevada, the Gigafactory spans 5.3 million square feet, making it one of the largest buildings in the world by footprint. When fully completed, it will cover over 13 million square feet and produce enough batteries to power 500,000 electric vehicles annually. The Gigafactory produces lithium-ion batteries for Tesla electric vehicles and Powerwall energy storage systems. By manufacturing batteries in-house, Tesla reduces costs, increases efficiency, and ensures a stable supply chain. The factory operates on renewable energy, with plans to achieve 100% sustainability. Solar panels cover the roof, and the surrounding area is designed for wind and geothermal energy generation. These efforts align with the mission of Tesla to transition the world to sustainable energy. The Gigafactory has created thousands of jobs in Nevada and attracted additional businesses to the region, boosting the local economy. The expansion is expected to add about 6,500 full-time employees and 4 million square feet of manufacturing space. It has also positioned the US as a leader in battery production and electric vehicle innovation. Despite its achievements, the Gigafactory has faced challenges, including construction delays and supply chain disruptions. Some critics question whether Tesla can meet its ambitious production targets.
It's time to travel to the state of Texas, where Tesla's Gigafactory is located. This sprawling facility, initiated in July 2020, underscores Tesla's commitment to scaling up its production capabilities, particularly for the Tesla Cybertruck, Model Y, Model 3, and Tesla Semi. Occupying over 2,500 acres along the Colorado River, Giga Texas is designed to be an eco-friendly facility, integrating closely with the surrounding environment. The site is one of the largest buildings in the world by footprint, featuring approximately 10 million square feet of operational space spread over several floors. This size equates to about 172 football fields, providing a visual of the vast scale of this project. The total investment by Tesla into this project is expected to exceed $1 billion, which is anticipated to inject significant economic activity into the local and state economy through direct employment and ancillary benefits to suppliers and service providers. Giga Texas is pivotal in solving the logistical challenges associated with Tesla's supply chain, aimed at reducing shipping costs and production bottlenecks. It is set to become a critical hub for Tesla's operations in the eastern United States, enhancing the company's distribution logistics across the East Coast and international markets. The factory's location was strategically chosen for its proximity to rail and road networks, facilitating efficient material shipments and distribution of finished vehicles. Next, it's time to talk about the Itaipu Dam projects, located on the border between Brazil and Paraguay. This colossal structure harnesses the power of the Paraná River, generating a staggering 14,000 megawatts of electricity. The dam plays a vital role in the energy supply of both countries, providing approximately 15% of Brazil's electricity needs and 75% of Paraguay's. Construction of the Itaipu Dam began in 1975 and was completed in 1984, involving a massive workforce and significant engineering challenges. The dam itself is about 4.8 miles long and 643 feet high, creating a reservoir that covers an area of 521 square miles. This reservoir, known as Itaipu Reservoir, has a total storage capacity of 29 billion cubic meters of water. One of the most impressive aspects of the Itaipu Dam is its power generation capability. The dam houses 20 generating units, each with a capacity of 700 megawatts. These units utilize Kaplan turbines, which are highly efficient for the varying water flow rates of the Paraná River. The power generated is transmitted through high-voltage lines to both Brazil and Paraguay, playing a crucial role in the economic and industrial development of the region. Environmental and social considerations were integral to the project. The construction of the dam necessitated the relocation of around 40,000 people and significant ecological changes, including the creation of the Itaipu Biological Reserve to protect local wildlife. The project also involved extensive reforestation efforts and the establishment of fish hatcheries to mitigate the environmental impact. Managed jointly by Brazil and Paraguay through the Itaipu binational entity, it stands as a testament to what can be achieved through collaboration. Let's take a look at the impressive Mercedes-Benz Stadium, home to the Atlanta Falcons and Atlanta United FC. Situated in the heart of Atlanta, this sports and entertainment facility is a testament to modern construction, with a staggering cost of $1.6 billion. The Mercedes-Benz Stadium project broke ground in 2014 and opened its doors in August 2017. Designed by Hawk, the stadium covers approximately 2 million square feet and boasts a seating capacity of 71,000, expandable to 75,000 for major events. The stadium is notable for its innovative retractable roof, which resembles a camera aperture and can open or close in just under 10 minutes. This unique design allows the venue to host events in both open-air and climate-controlled environments, providing flexibility for a wide range of activities. One of the standout features of the Mercedes-Benz Stadium is its 360-degree HD Halo video board, which is the largest of its kind in the world. This massive screen, which spans 1,100 feet in circumference, ensures that every spectator has a clear view of the action, no matter where they are seated. Additionally, the stadium is equipped with cutting-edge technology, including high-speed Wi-Fi and numerous LED displays throughout the venue. Constructing the Mercedes-Benz Stadium was a massive endeavor, requiring the efforts of over 4,000 workers during peak periods. The project faced several challenges, including the complexity of the retractable roof mechanism and the need to integrate numerous sustainable design elements. These sustainable features include a rainwater collection and reuse system, a LEED Platinum certification, and over 4,000 solar panels, making it one of the greenest stadiums in the world.
The Miami Signature Bridge is an iconic infrastructure project designed to improve traffic flow and redefine the city's skyline. With a cost of $818 million, this modern bridge combines functionality with architectural beauty. The Signature Bridge is planned as a 1025-foot-long bridge over NE 2nd Street and Biscayne Boulevard, and will redefine the skyline in Miami with 6 massive arches. The largest arch is expected to reach a height of 325 feet and be 650 feet wide. The design of the bridge includes sweeping arches illuminated by LED lights, creating a striking visual effect. It serves as a gateway to downtown Miami, connecting major highways and enhancing the aesthetic appeal of the city. The Signature Bridge is part of the I-395, SR-836, and I-95 improvement project, addressing congestion in one of the busiest corridors in Miami. By streamlining traffic flow, it reduces travel times and improves safety for drivers and pedestrians. Beyond its practical benefits, the bridge includes public spaces, pedestrian walkways, and green areas underneath. These features transform the area into a vibrant community hub, blending infrastructure with urban living. Construction has faced delays due to weather and logistical issues, but the project remains on track for completion in 2027.
Let's travel over to North Carolina, where the Charlotte Gateway Station is being constructed. This significant development, a central hub designed to integrate various modes of transportation, including Amtrak, buses, and future light rail services, is part of a larger vision to improve transit connectivity across the region. Scheduled for full operational status by 2025, the Charlotte Gateway Station began its early phases in 2018 with a budget projected to exceed $800 million by the project's conclusion. The station itself will cover several city blocks, featuring a state-of-the-art passenger terminal, bus bays, and extensive parking facilities. The project's total area is comparable to 20 football fields, emphasizing its scale and the transformational impact on the city landscape. It is expected to serve thousands of passengers daily, significantly easing the city's traffic congestion and providing a more efficient, reliable public transportation network. One of the primary challenges has been coordinating the multiple phases of construction while minimizing disruptions to the existing traffic and businesses in downtown Charlotte. The station's design features include expansive glass facades to maximize natural lighting and open public spaces that encourage pedestrian traffic, reflecting new trends in urban station aesthetics and functionality. In comparison to other transportation projects like the Moynihan Train Hall in New York City, the Charlotte Gateway Station is unique in its incorporation of green building practices and its role in catalyzing economic development in a mid-sized American city. Despite challenges such as budget adjustments and the complex logistics of constructing in a dense urban core, the Charlotte Gateway Station is set to become a critical node in North Carolina's transportation network. Next up, we have to talk about the Arena da Amazônia, located in Manaus, Brazil. This iconic structure not only serves as a venue for major sporting events, but also as a cultural and community hub for the region. Construction of the Arena da Amazonia began in 2010 and was completed in 2014, just in time for the World Cup. The stadium has a seating capacity of approximately 44,000 and features a distinctive design inspired by the Amazon rainforest. The roof structure resembles a basket weave, reflecting the local cultural heritage and providing an aesthetically striking appearance. One of the significant engineering challenges of the Arena da Amazonia was its location. Manaus is situated in the heart of the Amazon rainforest, presenting logistical challenges for transporting construction materials and equipment. The project required meticulous planning and coordination to ensure timely completion while minimizing the environmental impact. The stadium incorporates several sustainable design features, including rainwater harvesting systems, natural ventilation, and energy-efficient lighting. These features not only reduce the environmental footprint of the stadium, but also enhance the comfort and experience of spectators. The use of local materials and labor also contributed to the sustainability and economic benefits of the project. The Arena da Amazonia has hosted numerous international and domestic football matches, as well as concerts and cultural events. It has become a symbol of pride for the people of Manaus and a key attraction for tourists visiting the region. The stadium's design and construction have also received accolades for their innovation and sustainability. Let's take a closer look at the Second Midtown Tunnel project. Located under the Elizabeth River, the Second Midtown Tunnel connects the cities of Norfolk and Portsmouth. Its construction began in 2012 and reached completion in 2016. This project involved building a new two-lane tunnel parallel to the existing Midtown Tunnel, effectively doubling the capacity of this crucial traffic artery. With a cost of $2.1 billion, the construction process for the Second Midtown Tunnel was both innovative and complex. Unlike traditional tunneling methods, this project used an immersed tube technique. Prefabricated tunnel sections, each weighing approximately 16,000 tons, were constructed in a dry dock. These sections were then floated to the site, submerged into a pre-dug trench on the riverbed, and connected to form the tunnel. This method minimized disruption to river traffic and ensured precise alignment of the tunnel sections. The new tunnel not only alleviates traffic congestion, but also enhances safety and travel times for thousands of commuters. In terms of environmental considerations, the project included several measures to mitigate its impact. This included careful monitoring of water quality during construction and the use of innovative techniques to manage and minimize sediment displacement. The Second Midtown Tunnel also features modern safety enhancements, such as advanced ventilation systems, state-of-the-art lighting, and emergency response facilities. These upgrades ensure the tunnel meets contemporary standards for infrastructure resilience and commuter safety. Comparing this project to other major infrastructure endeavors, the Second Midtown Tunnel stands out for its strategic importance in regional connectivity and its use of advanced construction techniques. Next, let's examine the New Orleans Flood Protection System, a monumental infrastructure project designed to safeguard the city from devastating floods. This extensive system, with a staggering investment of $14.5 billion, stands as a critical response to the catastrophic impact of Hurricane Katrina in 2005. The system encompasses a complex network of levees, floodwalls, pump stations, and surge barriers designed to withstand a 100-year storm event. A key component of the system is the Inner Harbor Navigation Canal Surge Barrier, one of the largest civil works projects in the United States. This massive barrier stretches nearly 2 miles and features a series of gates and pumps that can be activated to block storm surges from entering the city. The INC Surge Barrier alone cost $1.1 billion and plays a vital role in protecting New Orleans from potential flooding. Another significant element is the Lake Borgne Surge Barrier, which extends for 1.8 miles and is designed to prevent storm surge from entering the Gulf Intracoastal Waterway and the Mississippi River Gulf Outlet. This barrier, coupled with numerous floodwalls and levee improvements, forms a robust defense against rising waters. The construction of the flood protection system was a massive undertaking involving tens of thousands of workers and extensive coordination between federal, state, and local agencies. The project faced numerous challenges, including the technical difficulties of working in a region characterized by soft, shifting soils and the need to protect the unique ecosystems of the Louisiana wetlands. In addition to physical barriers, the system incorporates advanced pump stations capable of removing vast amounts of water from the city's drainage canals. These pumps are essential for managing heavy rainfall and preventing water from accumulating in low-lying areas, which are particularly vulnerable to flooding. Next up, we have to talk about the Atlanta Beltline project. Envisioned as a comprehensive revitalization effort, the Beltline aims to convert a historic 22-mile railroad corridor encircling downtown Atlanta into a multi-use trail, modern streetcar line, and expansive green space. This grand project, which began in the early 2000s and is expected to continue in phases through 2030, is not only redefining urban transit, but also enhancing community connectivity. With an estimated cost exceeding $4.8 billion, the Atlanta Beltline is one of the largest, most wide-ranging urban redevelopment projects in the United States. It involves the coordination of multiple city departments and private contractors, engaging thousands of workers over its multiple phases of development. The Beltline addresses several critical urban challenges, including the need for improved public transportation options. By connecting 45 in-town neighborhoods with multi-use trails and transit options, it promotes a more sustainable lifestyle, reducing reliance on automobiles and encouraging walking, biking, and public transit. A notable feature of the Atlanta Beltline is its use of existing railroad tracks for the trail and transit system. The incorporation of art installations in parks along the Beltline has also turned previously neglected spaces into vibrant public areas that foster community interaction and cultural expression. The project has faced challenges, particularly in terms of funding and community engagement. Balancing the diverse needs and expectations of various stakeholders, residents, and city officials has required continuous dialogue and adaptation. But we haven't talked about the Punta Catalina power plant yet, located in the Dominican Republic. This coal-fired power plant has a total generating capacity of 752 megawatts, making it one of the largest power plants in the Caribbean. Construction of the Punta Catalina power plant began in 2013 and was completed in 2020. The project involved the construction of 2 generating units, each with a capacity of 376 megawatts, as well as supporting infrastructure such as a coal storage yard, a cooling water intake system, and an ash disposal system. The plant utilizes advanced technology to ensure high efficiency and low emissions, contributing to the country's efforts to improve its energy security and environmental sustainability. One of the most important features of the Punta Catalina power plant is its environmental management system. The plant incorporates advanced emissions control technologies, including flue gas desulfurization and selective catalytic reduction systems to minimize air pollutants. The project also includes measures to manage wastewater and solid waste, ensuring compliance with local and international environmental standards. The total budget of the Punta Catalina power plant project was approximately $2 billion, showcasing the country's great efforts. The project has generated significant economic benefits, including job creation during the construction phase and increased energy supply to support industrial and commercial activities. Comprehensive environmental impact assessments were conducted to identify and mitigate potential impacts on local ecosystems and communities. The project also included measures to engage with local residents and address their concerns, ensuring that the benefits of the power plant are shared with the surrounding communities. It's time to travel to San Francisco next, where the gigantic Chase Center is one of the city's biggest megaprojects. Located in the Mission Bay neighborhood of the city, Chase Center serves as a state-of-the-art arena primarily for the Golden State Warriors and a versatile venue for concerts and other events. This mega project, completed in September 2019, was a private sector initiative spearheaded by the Warriors' ownership, costing an estimated $1.4 billion. Chase Center covers an area of 11 acres and includes an 18,000-seat arena, 2 office buildings, 100,000 square feet of retail space, and a public plaza. The project also involved the creation of a waterfront park along with a half-mile of restored public waterfront. One of the challenges in its development was integrating the center with San Francisco's existing public transport networks. This led to significant improvements in local infrastructure, including the addition of a Muni Metro light rail platform and the enhancement of nearby roads. The use of cutting-edge seismic technology was a focal point, considering San Francisco's susceptibility to earthquakes. This included innovative base isolators and shock absorbers that ensure the arena can withstand significant seismic events. Chase Center's unique architectural design and construction methods included the use of sweeping glass facades and intricate metalwork that complements the bay's maritime setting. If you consider the height of the arena at nearly 135 feet, it stands tall enough to house the Statue of Liberty inside it, giving a sense of the scale at which this construction was conceptualized and executed.